Today we are going to continue the part that we did in the last class. So in the last class we started inclined motion. Okay, inclined motion, right? So let's move on to that part. So in the last class we start inclined motion under gravity. Okay, and we talk about the properties of the inclined motion, okay, also known as projectile motion, also known as projectiles, or we can call it as projectile motion, okay, motion, right? So we talk about the special properties in this motion. Okay, this is a type of motion under gravity. Right. So in the previous class we specially looked into the parts to derive main equations. Okay, in the previous class we derived equations in this part, so let me recall that. So this is finding the maximum height reached by the particle of a parabola. Okay, so we found this part. So usually in vertical motion under gravity, when an object is thrown vertically upwards and it falls to the ground, the equation to find the maximum height was what's it? It's u squared over 2g. So like we derived this equation in vertical motion under gravity, we derived this equation to this motion. Which motion? Inclined motion. So we say that the velocity of an object, okay, let's take it as u. This object is thrown with an angle theta to the horizontal. So what we did is we divided this velocity into two directions. Okay, one to the horizontal, we call it as the x-axis, and one to the upwards direction, we call it as the vertical direction, or we call it as the y-axis. Okay, so what we did was we took this and drew a triangle. Okay, so we have one x velocity and we have y velocity in the y direction, and if we add these two, we should come up with the velocity which is in this inclined region, which is in this inclined way. Okay, so since this is in the x direction, we name that velocity as vx. Okay, so generally, okay, this is general type. Okay, so since this is in the y direction, we name it as v. Okay, we name it as vy. Okay, vy, right? So what we did was, by using the laws in vectors, okay, by using these laws, what we did was we recall the theory in vectors. We know that we have parallelogram law, triangular law, and parallelogram law in vectors. And the next part is deriving finding the resultant force by using equation. These are the three parts to find the resultant force. Okay, so now we are going to use this triangular method. Okay, so I said that triangular method is every time head to tail method. The parallelogram method is every time head to head or tail to tail method. So we are going to use this head to tail method to derive this part. Okay, to find the vx and vy. Right, now what I'm going to do, I said that if you place this x, okay, I'll write here, if you place this x in this direction and name it as x, the head of this is here, in this dark green part, okay, and the tail of this is in this light green part. So head to tail method, in the sense you are going to again draw the vector y, okay, the velocity y, and I'll name it as y. Okay, now you are going to join the tail of this vector, okay, this is the head of this y vector, tail of this vector, this tail you are going to join it to the head of this vector, okay, that is known as the triangular loop. So what I'm going to do, I'm going to join this part, okay, right. So I'm going to move this and join it here, right, I joined it here. So the triangle, what does the triangular law say? It says when we join two vectors head to tail, in the method of head to tail, this is one point, the next point, the resultant will be obtained when we complete the triangle, okay, when we complete the triangle. So what we have to do, we have to complete this triangle, right? So now I'm going to use a different color. So what I'm going to do now, I'm going to draw this, I'm going to draw this triangle and complete this triangle. So we completed this triangle, and the next part that the triangular law says is the resultant will be the third side of the triangle, so the resultant here is the third side of the triangle, and that resultant is this side, okay, this side. So I will symbolize it by using double arrow. So this particular third side is gonna be this u here, okay, this u here, okay. So I'm going to mention it as u, okay, u. If not, I will mention this butter color, okay, u, okay. So what is this y? People? This y is from this, no, not this, sorry, not this. This y is from this vector, so that is this vy. So this y is the vector velocity, okay, velocity. Now the first unit makes sense, near the children. The first unit says that we did vectors part, so we are considering velocities here. So this velocity vy is considered as the y part, and the velocity vx is considered as the x part, okay, right. Now I'll erase everything that is not related to this part, okay, right, okay, fine. Now what we are going to do is, we know that this theta should be in where? Here or here, okay. Let's name this as A and this as B, this point as B. So what is theta, A or B? No, right. So theta is going to be the B part, okay. Theta is going to be the B part, so we have to mention that. Now I'm going to mention that this is going to be the theta, okay. I'll mention in a different color, okay. This is going to be the theta, okay, that is going to be the theta. Now we know that this is a right angle triangle, so we can apply trigonometric ratios. What are trigonometric ratios? Sine, cos and tan, okay. So we can apply these ratios, right. So what I'm now going to, my main target is to find this y and this x. Why we are going to find this y and x? Because we have to find this vx and vy, okay. We have to find this vx and vy, right. Now what I'm going to do, I'm going to find y with respect to what? This u, okay, this u. Y I'm going to find in terms of u, and x I'm going to find in terms of u, so that I have to build a relationship y and u or x and u, okay. So y and u is going to be something, and x and u is going to be something, okay. So these are the relationship. So we know that in trigonometric ratios, the relationship between the hypotenuse and the hypotenuse and the adjacent side is going to be cos, and hypotenuse and the opposite side is going to be sine, okay, sine. So these are the relationship that we are going to put into this part, right. Now let's put sine. Okay, let's find sine theta. Sine theta is going to be what? Opposite over hypotenuse. Opposite over hypotenuse. What is the opposite side? What's the length of the opposite side? It is going to be, people, that is y. Here that is y, so I'm going to mention it as y. Okay, the length is y, so here it is y. The length of this triangle is y. Okay, I took this length of the triangle. What is the length of the triangle? I mentioned the velocity. This vy, I took this vy as the length y to this triangle. Okay, vy as the length of this triangle. So now what I'm going to do, I'm going to write it. Right. So the opposite is going to be, I'm not going to write y, I'm going to write it as vy. Sorry, vy. Okay, vy divided by. So let's take this as, so now I'll take this as capital U. Okay, this is capital U, and this butter man is simple U. Okay, simple U. I took capital U as simple U. This is a velocity, this is a length. Okay, I took Vx as x. This is velocity, this both part, this is a subscript. Okay, this is a subscript. I took this whole part as x. This part is velocity. Which part is velocity? This Vx is velocity. This x is the length representing the velocity, and Vy is the velocity, and y is the length. Okay, y is the length. Okay, just I'm just recapping the previous class. Okay, right. So now what I'm going to do, I'm going to find this Vy. If I take sine theta, it should be y over u, but these are the lengths. Okay, so what I'm going to do, I'm going to take the respective velocity vectors, right? Respective velocity vectors, right? So instead of y, I'm going to take vy, and instead of simple u, I'm going to take what u? Capital U. So I'm going to put here capital U. Sorry, put here capital U, right? Capital U. So from here I'm going to take this sine theta here. Sine theta here is equal to vy over u, right? So this is the final verdict from this region. Verdict in the sense the final output, the final target. Okay, I mean the dream. Okay, our dream was to find what? Our dream was to find, or the aim was to find this vy, because the people who make questions just give us the velocity, the inclined velocity. We know we should know the vertical and the horizontal velocity. So what I'm going to do, I'm going to subject this vy. So I'm going to keep this vy here and put everything in the sense this u to this right hand side, sorry, to the left hand side, u to the left hand side. So this u is with a relationship of division. The division, since it is going to this next left hand side, that division is going to be transformed into a multiplication, right? So here in this region it is going to be u multiplied by sine theta, and now people, you all know that this is going to be what? This is going to be, we can write it as u sine theta. Okay, we don't want to mention here multiplication because you are now matured, right? You are A level student. So this is u sine theta, right? We came to the final part. We found that vy. Okay, I'm going to mention here. Okay. But vy is equal to u sine theta. Okay, u sine theta, right? Now what I'm going to do is I'm going to find vx. Now people see that here to find vy we used sine theta. To find x we should use what? Cos theta. I'm going to find cos theta. Same steps, just I'm going to copy paste it to a different part. Okay, delete. Now I'm going to find, I'll use a darker color, cos theta. Okay, cos theta. Okay, cos theta, this is going to be equal to what? Adjacent side adjacent side over hypotenuse, adjacent side over hypotenuse, right? What is the length of the adjacent side? Length of the adjacent side is x, so this is going to be x over hypotenuse is going to be simple u, okay? These are the lengths, so what do we know, what do we want? We want the velocities. So I'm going to write this is equal to Vx divided by capital U, right? Now I'm going to take this part and this part here, okay? So cos theta is equal to Vx divided by u. So I'm going to subject this Vx, so I'm going to keep this Vx here and move this u to this direction, so it is going to be u cos theta, okay? So I found this part, it is going to be Vx is equal to u cos theta, right? So we found that also, okay, right? So these are the main parts that you have to do before going into a question, okay? Going into an inclined motion question, right? So, right, since we are going to find this maximum height, I said that we can divide an inclined motion into horizontal motion as well as vertical motion, okay? Vertical motion and horizontal motion, but vertical and horizontal, okay? Horizontal. So the gravitational acceleration is related to this, not horizontal motion. If you take vertical and horizontal, this gravitational acceleration is related to this vertical motion. Gravitational acceleration is related to this vertical motion, okay? Vertical motion. And to find the maximum height that will be in the vertical direction, we have to apply these motion equations to which motion? If we divide inclined into two parts, we have to apply this to vertical or horizontal. Motion equations to vertical motion or horizontal motion? Vertical motion. Why? Because G will be acting towards the ground in only vertical motion, right? Okay. So what I'm going to do, I'm going to take the vertical velocity. I'm going to take only the vertical velocities, right? So the vertical velocity is going to be this part. Which part? This Vy. So my velocity now is going to be what? My velocity is, here it is u, here it is u, here if you see that it is u, but in my inclined motion part, the vertical velocity is going to be u cos theta. The 2 is going to be a constant from here. 2 is going to be a constant, and the next part is g. G is constant for this inclined motion and vertical motion. For vertical motion and inclined motion, the g is going to be constant. Why? It is the gravitational constant, okay? So this is going to be hm, okay? hm is equal to u cos theta over 2g, but there's a scared part, there's a scare here, scare value that is going to come here. The scare is going to come here, okay? Right, so let's rewrite it. So the hm is going to be, let's take the color, what is it? Let's take brown color. So hm is going to be equal to u cos theta, and it should be, this is the velocity, this is the whole velocity. It should be squared, right? Because there's a square, divided by 2 is a constant and g is also a constant. So the final equation is, we can simplify this bracket part, and we can come up to this squared belongs to this squared this squared belongs to this u as well as this cos theta. Okay, so we can rewrite this as u squared cos squared theta divided by 2g, and this is the final answer. This is the final answer, right? Likewise, let's write to every question, every b part. Okay, what is the b part? They're asking the find the time taken to reach the maximum height. Okay, maximum height. So we know that the time taken is t m. This will be equal to u over g. So definitely this is going to be equal to what? This is going to be equal to Tm in inclined motion. G is going to be a constant. U is going to be what? U cos theta. Why u cos theta? If somebody asks me, why are you going to use u cos theta without u sin theta? The reason is simply this: u cos theta is the vertical component. U sin theta is the horizontal component. So if a student asks which component affects the vertical motion, which component affects the vertical motion, people? Which one? This vertical part should affect the vertical motion. So to find the maximum height or the time taken to reach the maximum height is in vertical part, people. It is not in the horizontal part. In horizontal part we mention it as range. We talked about that. So when an inclined object is projected, it falls like this. So this vertical part is going to be r, range. This part is going to be hm, what? Maximum height. Height means every time it should be in vertical part. It should be the vertical part. Okay, so to find the maximum height we should apply this to what? Vertical motion. So vertical motion in the sense we have to put that to u sin theta or u cos theta. U sin theta. Okay, I did a small wrong here. The thing I did wrong here is the thing is here. Sorry, I did a small mistake. The thing is this vy, we have applied vy. Okay, the vertical part is vy. So vy is sin theta, people. Sin theta. We mentioned it as cos theta. Okay, this should not be cos theta. A small mistake. Okay, let's correct it. It's simply easy. Select this part. Okay, select this part. Okay, wait. Select this part and delete it. Okay, this part, whole part, and delete it. So what's the part that should be here? That is sin theta. Okay, sin square theta. So again here the same mistake. I took cos theta. It should be sin theta. So this is the maximum height, u sin theta over g. Okay, u sin theta over g. Okay, so let's move on to okay, let's correct this here. Okay, fine. Let's move on to the next part. What is it? Finding the flight time of the particle. So the flight time of the particle for the vertical motion under gravity is 2u over g, twice the time taken to reach the maximum height. So this part is going to be in inclined motion. What? This u is going to transform into tf is equal to what? u 2u sin theta divided by g. This is the time of flight. Right. Okay, so now let's go to this part. What is this? Finding the maximum horizontal range. So there's no any horizontal range in the vertical motion under gravity. Vertical motion under under gravity. There's no any range. Range in the sense it is the horizontal. It belongs to the horizontal part. Why I said a body moves like this, a body moves like this. Okay, a body moves like this. So this, the length from here to here is going to be the range. So this horizontal part, this length is horizontal. This is the horizontal direction. So what we have to apply the motion equations to the horizontal part. We have to apply motion equations to the horizontal part. Right. Okay, horizontal part. Delete this and this. Delete this. Delete. Okay. Right. So we came to one equation, and that equation was what was it? It belongs only to the what inclined motion. It is equal to range. We symbolize it by capital R is equal to u squared sine 2 theta divided by g. So this is the summary of the previous session. Okay. Okay, right. Okay, right. Now let's move on. Now let's go on to the today's part. Okay. So I gave something to write here. Okay. I said that the maximum range that we can obtain is by throwing an object in what angle? 45 degrees. That is the angle which we can reach the maximum range. Okay, right. So now let's move on to the solved exercise part. Now here is the officially today's class part. Okay, this is the today's official class part. Right. Okay. Now let's look into this question. Okay, now let's look into this question, draw a beautiful diagram and solve this exercise. Right. Okay. So what's this question? A bullet is projected upwards with a velocity of 160 meters per second, inclined by an angle of 30 degrees to the horizontal. Right. These are the main informations that we have to take from this particular question. This 60, 160, 30 degrees, and this to the horizontal part. So what's the meaning of this? 160 degrees inclined, okay, velocity, but the velocity is 160 meters per second, inclined with 30 degrees to the horizontal. So horizontal is going to be this is horizontal, this is vertical. Okay, this is vertical, this is horizontal. So they say that 30 degrees to the horizontal means this angle is going to be 30 degrees. Okay, so there can be questions, they will mention this to the vertical part, then you have to take this as the angle, but now you have to take this as the 30 degrees part. Okay, this is 160 and this is the horizontal part, right? Okay, now let's move on to the question and draw a diagram. So this diagram will be like this. Okay, right. So let's go into a beautiful dark color. Okay, dark color. Let's take a black ash. Fine. Now this is a motion, so this will be an inclined motion. So this will be like this. Okay, let's decrease this to like here. Okay, this will be like this. The motion will be like this. Okay, a projectile motion. So here, people, you have the horizontal component and the vertical component. Okay, horizontal component and the vertical component. Okay, fine. And the velocity is going to be, the projected velocity will be how much? It is going to be 160 meters per second. Okay, fine. So now what I'm going to do, I'm going to mark this range. So this is going to be the horizontal range, and this is going to be the height. What height? Maximum height. And I will mention this as the horizontal range. Okay, horizontal range. Okay, this is the horizontal range. Fine. So the next part I have to mention here is the angle. So this angle is going to be 30 degrees. 30 degrees. Okay, now what I'm going to do, I'm going to name the horizontal velocity as u1 and vertical velocity as u2. Vertical velocity as u2. That's all. Right, now let's move on to the question. So the first part is to find the maximum height reached by the bullet. Maximum height reached by the bullet. Right. So before everything, what we have to do is we have to write everything. Okay, before doing the question, write everything in the sense, write this velocity. Okay, this velocity and this velocity. Okay, this velocity and this velocity. Right, let's do it. So horizontal, okay, start right with me, horizontal component of the projected velocity. Okay, try to write this in what, in one sentence. Okay, one sentence. If not, okay, horizontal velocity, I'll try to write in one sentence. Horizontal projected velocity, comma. Okay, horizontal velocity is going to be what is it? It is u1, people. It is going to be u1. Okay, u1. So u1 is equal to, what did I say? The horizontal part. I said the easy method to find the horizontal part is to, if this is 30, this angle, the component with the angle is this. This is the component that is with the angle. Okay, that is going to be what? If this is u, this is going to be u cos 30. So the cos part is going to be with the angle. So cos is going to be adjacent over hypotenuse. So cos will be with the adjacent side. So this is going to be the opposite side. So this will be u sine theta. So what I'm going to do, I'm going to use this part, I'm going to use this theory and find this horizontal and vertical components. Right, so now u1 is going to be what cos theta, what cos 30, 160 cos 30 degrees. So u1 is going to be equal to, okay, let's find it. So you all know that 160. Okay, 160. So I'll do the workings here. Okay, I'll keep this reference part. Okay, sorry, I'll shift this reference part here a little bit here. Okay, now what I'm going to do, I'm going to do the workings here. So u1 is equal to 160 cos 30. So 160, what is cos 30, people? Cos 30, I have said dual cos, what I have said dual. Every time remember this code, what? Cos hatter bhage in the sense, sorry, not here, it's not here. Okay, it's more to here. So I say that cos hatter bhage, remember that cos hatter is going to be bhage. So cos hatter is bhage. So wait, cos 30 is going to be what the next part? What's the next part? The next part is going to be what? Root 3 divided by 2. Simple as nothing. Okay, root 3 divided by 2. Now I'm going to write here root 3 divided by 2. So now I can cancel this 2 is 160. This is going to be 80 and this is going to be 1. So the final answer is going to be 80 root 3. Okay, 80 root 3. So I'm going to write this down here. Okay, I'll write it. So u1 is going to be 80 what? Root 3. That's all. I'm going to do the solvings here. Okay, scratch work is here, scratch work is here, and I'm going to finalize it here. Okay, that's all. Fine. Now let's move on to the next part. Next part is the vertical velocity. Vertical velocity. Likewise, you wrote the sentence here, you have to write the sentence here. Okay, you have to write a sentence here. Okay, you have to write a sentence here. Okay, you have to write a sentence here. So the next sentence will be what? Vertical component of the projected velocity, and that will be equal to u2, and that is equal to 160. What? When this is sine cos 30, this will be sine 30, that will be sine 30. So this will be sine 30 degrees, so u2 is equal to I have said that when cos something is equal to root 3 over 2, the opposite of cos will be sine, so it will be the opposite of root 3 over 2. So I have said root 3 over 2, the opposite of it will be what? 1 over 2. Root 3 over 2 and 1 over 2 is the couple, so the opposite of root 3 over 2 is half. So that's why cos 30 and cos 60 is related in this relationship. Okay, so likewise we can relate cos with sine, and here also it will be the opposite of this, so this is root 3 over 2, this will be half, this will be 1 over 2. So here if we write cos 30, 160 multiplied by sine 30 will be this, half. So this will be, this to this cancel off, this is 80, so this will be 80. It's just simply 80, right? So I will mention that. Okay, this will be 80 what? 80 meters per second. Okay, so here also it is meters per second. So I found the horizontal and the vertical velocity, right? Let's move on to the next part. Okay, let's move on to the next part. Okay, so the first question, now we are going to move on to the first question. So what is the first question? The first question is to find the maximum height reached by the bullet. Okay, so we are going to find this h. Okay, h. So what we know is we can name this. I said that you have to name every motion before doing that question. So I said in an inclined motion you have two boundary conditions. The first is the starting point, and next the ending point. Not two, since this is an inclined motion, you have the third boundary condition. Okay, you have the third boundary condition under gravity. This is the maximum point. You have three boundary conditions. So I am going to name these boundary conditions with some alphabetic letters. Right? I am going to name this as A, this point as B, and this point as C. This point as C. Okay, C. Okay, now I'm going to apply these motion equations. To this part. Which part? I have to find the maximum. I have to find the maximum height. So I have to go to this point from the initial point. From this initial point to this maximum point. So I have to apply this from A to B. I have to apply this from A to B. So I'm going to write it here. A to B, I have going to apply equations, right? So let's see what are the data that we all know. We know that the initial velocity. So we are going to apply A to B. We are going to find this. Vertical part. We are going to find this vertical height. So we have to apply this to the vertical component. In the sense we are going to use u2 in the sense it is going to be sine 30 in the sense 80 meters. We are going to use this part. Okay, we are going to use this part, right? So we are going to apply motion equations to that. So we know the initial velocity in that direction and we are going to apply for A to B. So we know the final velocity in the vertical part. So we know if we take the vertical part at the maximum height, at the maximum point, the vertical component, the vertical velocity will be equal to 0, equal to 0. The vertical velocity will be 0. At this point, the vertical velocity will be 0. It is not moving up or it is not moving down. It's not moving up or not moving down. So this will be 0. This will be 0 at this B point. Okay, so we know the initial velocity and we know the final velocity, and we have to find this height, and the next data is the the gravitational acceleration. So we know 4 data, so now we can apply that, right? So let's write them. We know u, the initial velocity is what? u2, so it is going to be 80, and we know the final velocity, that is going to be 0, and we know the acceleration will be g, okay, will be g in the sense it is going to be 10 meters per square second. 10 meters per square second. I'm not going to mention the unit, so it is 10. So let's see how this 10 will apply, positive or negative 10. And then we have the height, that is what we have to find. The s, it is the height, it is going to be h, Now tell me guys, I'm going to apply this to this in this direction, which is in the upwards direction. So the gravitational force will act in the downwards direction. Let's mark it. Let's mark that gravitational force here. Gravitational force every time is in the downwards direction. It is g is equal to 10 meters per square second, right? So this is g, this is the, since we applied in the upwards direction, the g will be minus g. Since this is acting in positive direction, if we consider the downwards, since this is acting in the downwards direction, if we consider the upward part, this is going to be negative, okay, this is going to be negative, okay, right. So now this g, this a acceleration will be, negative, right? Now what we are going to apply, we have u, we have v, v, a and s. So we are going to apply, but u squared equal v squared plus 2as, right? We are going to apply this to the upward direction. What? V squared equal u squared plus 2as, right? 2as. So this will be equal to what? The if final velocity is 0, the initial velocity is 80, so I'll write 80 squared plus, okay, plus. So I know that since the acceleration is negative, this whole part is going to be negative, so I'm going to take this positive as negative now, okay. 2, the acceleration is going to be 10, and the height I have to find it, right? So now what can I do is, I can write this whole step, in this direction, and write this whole step in this direction, and this part in this direction, put the equal sign, okay, that's good, right? Now let's write, okay, here I can write, this will be what? This will be 20h, okay, 20h, and this is going to be 80 times 80, that is going to be 6,400. So I'm going to write this in that way, okay. So wrote this 20h in the left hand side, that is equal to 6,400. So h will be equal to right, h will be equal to what? So it will be equal to, let's write it here. So h will be equal to 6,400 divided by 20. This to this cancel, 640 divided by 2, 320. So h will be equal to 320 what? Meters. So this step is not relevant because that's an intermediate step. So in here I am not going to write this. Okay. If you want, you can try this. I'm not writing that to save space. Okay, right. Okay, now let's move on to the Roman number 2. Okay, Roman number 2. So I'll move this part here. A little bit here. Okay, and part, I'll move it here and put some red lines, okay, to separate that and this, or just like this part. Okay, fine. Let's move on to the second Roman number 2. Okay, let's move on to Roman number 2. I think this is not that much important. I can minimize this somewhat smaller to here. Okay, right, to here. So if you want, you can write it. If you want, you can write it. Okay, for your practice. So the next one, I'm going to move on to the Roman number 2 part. I'm going to move on to the Roman number 2. So the Roman number 2 is to find the time taken to reach the maximum flight. Time taken to reach the maximum flight. Okay, time taken to reach the maximum flight. Okay. So let's find the time taken to reach the maximum flight. So again, I'm going to apply this from A to B. Okay, A to B. So this will be in the vertical part. Okay, vertical part. The initial velocity will be the vertical one. So that is 80, and we know the final velocity, that is going to be 0, and we need the time. Let's take it as t, and the next part is acceleration. Since we are applying this into the upward direction, the acceleration is going to be minus 10. So that's all that we have to do. So I'm going to apply this in the vertical part. So UVTA, the equation is going to be V is equal to U plus AT. V is equal to U plus AT. Final velocity is 0. Initial velocity is 80. Since the acceleration negative, I'm going to write negative here. So 10 multiplied by time is t. So take this part to here, take that part to here. So that will be 10t equal to 80. So t will be equal to 80. Sorry, t will be equal to 80 divided by 10. So this will be 8. This will be 8 what? 8 seconds. 8 seconds. Okay, 8 seconds. So this step, I don't want that. So I'm deleting. So I don't want this part also. These are simplifying parts. To be clear, I will take this here and this part here. Okay, that's enough for you. Okay, I'll erase it and I'll take it. So the time is going to be how much? The time will be how many seconds? 8 seconds. Okay, 8 seconds. Fine. So now I'm going to move on to the third question. Okay, third question. Right. The third question is find the flight time of the bullet. So flight time of the bullet, I have to put equation. Flight time from here to it is flying like this, like a rocket is flying like this, and it's coming to C. It is coming to point C. Okay, so the flying time is from A to C. So from A to C. Okay, from A to C. Okay, right. So from A to C, I'm going to apply the equation. So for this motion, to find the time of flight, what did I do is, to find the time of flight, I have found the time of flight in vertical motion under gravity. So for that, I have to put the equations to the vertical part or the horizontal part, people. Okay, I have found the time of flight in the vertical motion under gravity part. Okay, now we're going to apply the same time of flight equation to the inclined motion part. But in inclined motion, we have two sections as the vertical part and the horizontal part. So to find the time of flight in the inclined motion, what we have to do, we have to apply the motion equations to the vertical part or the horizontal part. To which part? We have to apply to the vertical part. Why should we apply that to the vertical part? Because we remember that we applied time of flight, we derived time of flight equation to the vertical motion under gravity. So time of flight is every time related to which motion? To the vertical part, every time to the vertical part. Okay, so the gravity is the physical quantity that affects the time, right this in your notebook. Okay, this is a beautiful thing that Einstein developed. Okay, gravity is a physical quantity that affects the time, okay. So therefore the gravity is evolved, I mean gravity is in the vertical motion. Okay, it is not in the horizontal part. So definitely, to find something about time, remember this, definitely to find something related to time in motion. What motion? In motion under gravity, there should be g in that equation. So in that equation there should be g every time, because when it comes to gravity, that is the physical quantity that affects the time. Okay, so now I'm going to apply this to we found the limits. Okay, we found the limits. Now I have to find the direction. Okay, I found the direction. Now what is my purpose? My purpose is to find the equation. Which equation? We have to substitute this parts. So we have 4 equations. Out of the 4, which one is the equation that you are going to choose? Okay, now let's see the variables that we all know. So we have to find the what time of flight. We have found the time maximum. Now we are going to find the time of flight. Okay, so I know the initial velocity, that is going to be 80. Right, I know the final velocity. Do I know the final velocity? Yeah, I know the final velocity, since it is going upwards and it is touching the ground from in the same position, in the same vertical position. The velocity is going to be here. The v is going to be the negative of the initial velocity. Okay, fine, we know that, but now I'll consider that we don't know the final velocity. I'll consider that we don't know v, but we know that since it is returning to the initial position, it took off from here. Okay, took off like a bullet. It went here, and it's now falling down. It's down, and it is touching the ground at the same vertical position. This is the same vertical position. One vertical position. Okay, so the distance from here to here, that the vertical distance from here to here, that means the vertical distance from here again to here, what is it? It is 0. The vertical distance, there's no any distance, same location, it came to the same vertical location, so the distance is going to be 0. Understand? Right, so we know that the displacement from A to C is going to be 0. Fine. Okay, so the next part is we have to find t. So I'm going to write t as t. I'm going to find t as t. And the next part is we have to find t. So I wrote that time as t. And the next part we all know is every time a, the gravitational acceleration is going to be -10. Why -10? We are going to apply it to the vertical upward part, right? So what are the variables? U, S, T, A. So the equation is S equals ut plus half at squared. Okay, at squared. To save space, I wrote this fraction in this way. Okay, so the displacement is 0. Okay, the displacement is 0, and the initial velocity is 80. The time of flight. Okay, since we took t for the above part, let's take this as capital T. Okay, this is capital T, and since a is minus, I'm going to write this part as negative. Okay, negative half a is going to be 10 multiplied by capital T squared. So this to this is going to cancel off. 2 to this 10 is cancelled off. This is going to be this is going to be 5. Okay, so now what I'm going to do, I'm going to take this part, this region to right hand side, so this will be 5t squared is equal to 80t. I can cancel this 5 to this 80, so this 80 will be, this 80 divided by 5 will be equal to what? 80 divided by 10 is going to be 8, so 80 divided by 5 is going to be double of 8 is 16. So we have that t squared equals to 16t. We can cancel 1t to 1t here, because the reason is t is what? T is every time greater than 0. Why it is greater than 0? Since this is time of flight is greater than 0 here. So we can write here what? We can find it. We can write the relationship like this, and we can write t is equal to 16. Why 16? Cancel this to this. This is 16t, 1t to 1t. So what is remaining is only 16. Okay, only 16, right? Only 16. Okay, now I'm going to erase the irrelevant parts. We don't need this and this. We don't need this. Okay, we don't want to show this. We don't want to show this. We don't want to okay, so we are going to erase this. We don't want this 16. Okay, you just write it here. Cancel. We don't want to write the cancelling parts. Okay, I mean the exact steps that we need to finalize the answer is this. So why is this? Why did we cancel this? Because t is greater than 0. These are the exact steps. These are the exact steps that we have to write in the what? Exam paper. Write in the exam paper. Okay, so the answer is going to be t is equal to 16. T is equal to 16 what? 16 seconds. 16 seconds. 16 seconds. Fine. 16 seconds. Okay, right. Now let's write everything. Okay, write everything here. Fine. Okay, so let's write everything here. Fine. So the fourth question, let's move on to the fourth question. Fourth question is going to be the fourth question is find the horizontal range made by the bullet. Find the horizontal range made by the bullet. To find the horizontal range, I have to apply motion equations from here to here, here to here. That is range of this, here to here. So I'm going to start with A to C. Okay, I'm going to apply this. Since I'm going to find the horizontal, I have to apply these equations in which direction? In this direction. Not vertical, horizontal, right? Okay, fine. So what I'm going to do is I'm going to see the variables. Okay, do I know the initial velocity in this direction? Yes, I know the initial velocity in that direction. That is going to be u1. That is u1. That is equal to how much? 80 root 3. Here every time we applied u2. Okay, every time we applied u2. This is u1. We know u1, and the next part is we have to find the time. But from A to C, we know the time period. What is the time period? That is the time of flight. So that time of flight we found here, that is 60. So to come from A to C point, the time that is consumed, the time to come from A to C is going to be t is equal to how much? 16. T is equal to 16. Right? So we have to find S. We know that A is equal to 0, right? No acceleration in the horizontal part, because it is moving in a uniform velocity. Why? In this horizontal part, people, you have to remember that there are no any forces. Why? There are no any forces in the linear motion part. You have a different category under the second unit as Newton's law of motion. So after you finish Newton's law of motion only, you are going to have forces. But before that, you have the linear motion. This is linear motion. So in linear motion you don't have any forces. Okay, the only force is the gravitational force. That is the weight. Therefore we consider the accelerations. We know F is equal to ma. Since there are no any forces, we don't have any acceleration. So acceleration is 0 in the horizontal part, but in the vertical part we have a force, that is the weight, so weight means we have g is the gravitational acceleration. It has an acceleration. The force is weight, the acceleration is gravitational acceleration. Understand? Therefore, when we are applying equations to the horizontal direction, okay, write this as a statement, then you will remember this. Okay, write this as a statement. Okay, what's the statement? Just write it. Okay, I'll write it in red color. Okay, since this is point. Okay, this is a highlight. Let's use magenta. Okay, I'll write it here. What's the point? In the horizontal part of an inclined motion, the acceleration is 0. Okay, 0. In brackets you have to write because there are no any forces. Without forces you can write not forces. The superior part is because there are no any unbalanced forces. Unbalanced force කිව්වත් ඇති, so let's put as unbalanced force. Okay, unbalanced force. Right, now let's move on to our part. So I know that I'm going to apply the equations to the horizontal direction. So in this horizontal direction, since I don't have any acceleration, I'm not going to take this part. So when you don't have an acceleration, the equation is, every time you have only one equation, that is going to be s equal ut. This is the all-level knowledge. Okay, this is all-level knowledge. So we are going to apply s equal ut here. S equals ut. S is equal to ut. So let's find s. S is equal to, the initial velocity is 8√3 and the time is 16. So this will be equal to, the s is going to be, the s here is capital R. What is it? Range. So R. So R will be equal to 80 multiplied by 16√3. So I'm going to multiply 80 and 16. 80 multiplied by 16. Okay, so let's multiply this 8 by 16. So the easiest way is to multiply 16 by 80, because there's 0. 16 multiplied by 80. 0 times 0, 0 times 0, 0. 8 times 6 is 48. 8 and 1 is 8, so it is going to be 120. So the final is 1280. Okay, 1280. Fine, 1280. Okay, so the range is going to be 1280√3. 1280√3. Okay, so here this is not the final answer. What you have to do is you have to write this √3. I have said the value of √3 is every time. Okay, this is 1280. Value of √3 is 1.732. So what you have to do, you have to multiply this and write the final answer in decimals. When you multiply this, the answer will be it will be 1280 multiplied by 1.732. The answer will be 2216 sorry, this is not here. 2216 0.96. So this is going to be the range. So every time if they say to round off this to the whole number, nearest whole number, so you can round off this as, you can write this as 2217. Okay, this is rounded off to the whole number. If they say to round it off to the second decimal place, you can keep it like this, if not you have to keep it like this. Understand? So in this theory note, you don't have to write it in the decimal way. If you want, you can write this. Okay, all right, write this, and if you need, you can write this will be also equal to 2216.96 what meters. This is also meters. Okay, so okay, fine. One solved exercise is completely finished. Okay, right, let's move on to the next part. Okay, right, now let's move on to the solved exercise 12. Okay, right, now let's read the question. The question is, find the velocity. Now we have to find the velocity and the direction of motion, and we have to find the direction of motion after 6 seconds of an object projected upwards, with a velocity of 192 meters per second at an angle of 30 degrees to the horizontal. So what they're asking is, they have thrown an object with an inclination of 30 degrees with 192 meters per second, and it is going like this, and they're asking at the sixth second, what is the velocity of this object. So if we take the velocity of this object, this velocity has two components, the vertical and the horizontal component. What we have to do is, we have to apply motion equations and find the Vx, the vertical component, and this Vy at this 6th second, and we have to combine this and find the final velocity. Okay, but we find the Vx and we add Vy. This is in horizontal direction, this is in vertical direction. Since these are vectors, we have to use triangular law and find this final velocity and this angle is the part that they are asking. Direction, find the direction and the velocity. We have two components, horizontal and vertical, and taking this to this part and taking this to this side of the triangle, we are going to build a triangle and build the third side, and this third side is going to be the final velocity. This is going to be the final horizontal velocity, this is going to be the final vertical velocity, and this is going to be the final resultant velocity, and the angle built here is going to be the direction. Wow, this is really beautiful. Okay, fine, now let's move on to the question. Okay, so the solution, we have to draw the diagrams. Okay, so here the ball is moving, the object is moving like this. Okay, it is moving like this. So the vertical velocity, we have to find it, and the horizontal and the vertical velocity, we have to find them. Okay, right. So after 6 seconds, let's assume that, let's take the ball is here now. After 6 seconds, the ball would be somewhere here. Okay, right. At this point, it has a horizontal velocity and it has a vertical velocity. Okay, two velocities, and in this position and the initial position, you have the initial velocity, and in this position you have the final velocity. Okay, now what I'm going to do, let's put it into this area eraser. Okay, now I'm going to erase this up to here. Okay, fine. Okay, so I'm going to write the final velocities. Sorry, what can I do? Okay, I erase this stroke eraser. Okay, so let's draw the final velocity like this, a little bit darker, and this final velocity also like this. Okay, right. So I'll mark this as in this way and this in this way, this in this way, and this in this way. Okay, so the final velocities I will mark it in double arrows. I mean resultant velocity, initial resultant velocity, and here final resultant velocity. Okay, right. Now I'm going to select the whole diagram and move it a little bit downward. Okay, a little bit downward here. Alright, you have to draw this diagram like this. Okay, oh fine. Now I'm going to name this. So this is 192 meters per second. This is 192 meters per second. So horizontal velocity is u1, vertical velocity is u2. Right. So the final velocity is, it is going to be v. So the horizontal part here is going to be v1 and the vertical part is going to be v2. Okay, fine. This is the diagram. So here we have to mention one part. What is it? We have forgot to mention it. It is the angle. It is the angle of inclination. So it is going to be it is going to be it is going to be 30 degrees here, and here it is going to be, we have to find it, we have to find this angle. Okay. Oh, it is not working. Okay, this is going to be somewhat whatever the angle, we don't know. So for now we are going to mention it as alpha. So the final solution that this question expect is the velocity and the direction. So they need this alpha and they need this alpha. Oh, that is, we have to change this color, yellow. Oh, that's better. We have to find this alpha and we have to find this v. We have to find this alpha and v. That is the final final solution that we need expect from this question. Okay, now let's write a small sentence and start the question. Okay, what is it? Since the horizontal velocity is kept constant, okay, since the horizontal velocity is kept constant, so since no, the next, okay, let's try it in this color. Since the horizontal velocity is kept constant. Okay, why it is kept constant? Because there is no any force in this or this direction. So this u1 is kept constant. In the entire motion it is u1. So the vertical horizontal part here is going to be the exact same part. Why? The horizontal velocity is not going to change. Since the horizontal velocity is kept constant throughout the entire motion, the entire motion of the projectile v1. Okay, let's write in the next color. v1 is going to be equal to u1. Okay, what is u1? We are going to find them. Okay, right. So after that we have to find the v2 and stuff. Okay, now what's the target of our the final target is to find velocity and this. So before starting any question, what we have to do in an inclined motion, the first step in an inclined motion is to find the horizontal and vertical velocities. Velocity. Okay, we have to find that, right? So first of all, I'm going to find u1. u1. Okay, u1. So u1 is going to be what is it? It is going to be with the angle. So it is cos theta or sin theta, people. It is cos theta. So u1 is equal to 192 cos theta, that is 30 degrees, cos 30 degrees, cos 30 degrees. Therefore u1 is equal to 192 multiplied by cos 30 is, now I said that cos hat bhagya, so cos 30 is going to be mole deka bedima deka, that means root 3 over 2. So this you can cancel off. This is going to be 90, sorry, not 196, this is going to be 96, just 96, this is 96. So the final answer is 96 root 3, 96 root 3, okay, 96 root 3, fine, okay, 96 root 3, okay. So let's go to find the u2 is this vertical part. So vertical part is, horizontal part is cos 30 with the angle cos, without the angle here it is going to be sine, so 192 sine 30 degrees, 192 sine 30 degrees, this is going to be equal to, so what is it, 192 multiplied by sine 30. I said the opposite of root 3 over 2 is every time half, opposite of root 3 over 2 is half. So this will be equal to this, to this cancel off, this is going to be 96, this is going to be 96. So we found u1 and u2, okay, right. Okay, now we found u2, right, and u1. So here I have said in the statement, since the horizontal velocity is kept constant throughout the entire motion of the projectile, v1 should be equal to u1. v1 should be equal to okay, right. So this v1 will be equal to this u1, okay. So we know that v1 is equal to u1, but u1 is equal to what u1 is equal to 96 root 3. u1 is equal to 96 root 3, okay, we know that. So next what we have to do is to find what we are going to find. We found v1, now we are going to find v2. We are going to apply in this direction, okay, we are going to apply in this direction, okay. So v2 is in the what, vertical direction. So to find that we have to apply motion equation, right, okay. Now let's move on to that part. So let's see what are the physical quantities that we all know until now. So we know the initial velocity, that is u2 in the vertical direction, u2, that is equal to 192 divided by that, so it is going to be, sorry, it is going to be 96, and then we have to know the final velocity. Let's take the final velocity as v2. Why? We have to find this v2, okay. And what are the next factor? We know the gravitational acceleration, and we are going to apply this in the what, upward direction. So it is going to be minus 10, because gravitational acceleration every time downwards part. And the next part is we have to find from here to here, from this part to this, from this location to this location to this location, from this location to this location, okay, from this location to this location, the time period taken is equal to, this is t equals 0, this is equal to 6 seconds. That is the data from the question, okay, that is 6 seconds. So here t should be equal to 6, right, that is equal to, t is equal to 6, so we know u, v, a, t. So we are going to apply which motion equation? We are going to apply v is equal to u plus a, t is equal to u plus a, t. From where to where? From point A to from point So we have to mention that A to point B. Okay, from A to point B, B is equal to U plus AD. So V is here going to be V2, U is going to be 96 root 3. Since this is negative, we are going to put negative because 10 is negative. 10 and the time is going to be 6. Time is going to be 6. So here the V2 will be equal to 96 root 3. Subtract 10 times 6 is going to be 60. So if you solve this, sorry, I did a small mistake. The mistake is here U2 is 96. U2 is 96. I took it as U root 3. It is 96. Here this is minus because 10, negative 10 multiplied by time is going to be 6. So V2 is equal to 96 minus 60, that is going to be 36 meters per second. We found V2. Okay, right. So the targets that we had, we achieved them. Okay, we found this, and we found what did we found? We need this and this. We need mean velocity. I'll mention that. We need this. Okay, we know what this. We know this V, and we need this alpha. So to find this V, let's take a purple color. We want this and we want this. To find this, we need this V2 and we need this V1. So our ultimate goal is to find these objects. Which objects? Let's take a blue color. This V1 and this V2. So from there we can find the where's the color? We can find this V, and from here we can find this V by adding them. So we can easily find this man, and after that we can find this alpha. Okay, right. So we found V2. Now we are going to find that final velocity. Right. For that we have to draw a vector diagram. Okay, vector diagram. So I'm going to draw a vector diagram. I know that the horizontal velocity is V1. Horizontal velocity is V1, and that is equal to 96 root 3. Okay, 96 root 3. And I know that the vertical velocity is going to be how much? Vertical velocity is going to be V2. So it is V2, and that is equal to V2 is equal to 36. Okay, we found that 36. Okay, so when we add these two vectors, when we add this vector and this vector, we will get sum of the vectors, and that will be in between these two. Okay, right. I'm going to draw that vector. That will be right here. Okay, it will be like this. Okay, this is the resultant vector. So I will name it as V. Why V? Because I have taken that V here. I have taken V as the resultant of V1 and V2. Right. So when we mention this vector, it is inclined to the horizontal. So since it is inclined, when we draw an inclined object in physics, we have to mention this angle, that is alpha. Right. So we know this. So we know this is a triangle, and it is 96 root 3, and the height of this is 36. So this is alpha. So we can find the tan alpha from here. That is equal to tan alpha is equal to tan alpha is equal to opposite over adjacent. So 36 divided by 96 root 3, and from there we can find tan alpha by using trigonometric tables. Alpha we can find it by using trigonometric tables. Understand? So that is the main target. To find this v, we have to find the length of this side. We have to find the length of this triangle. So for that, we have the adjacent sides length and the opposite sides length. So what we are gonna do is we are going to use Pythagoras theorem and find this v. Right? So we know that the equation to find that velocity is what? V will be equal to square root of v1 squared plus v2 squared. Square root of v1 plus v2 squared. So this will be equal to 96 root 3 squared plus 36 squared and square root of this. So if you calculate this, you will get to an answer as 170 meters per second. And that is the answer. Okay, we found that. So this is not only our target. Okay, this is not the target. This is one of our target. The next target is to find the angle also. We have to find that angle also. Right, now I'm going to find the angle. So now for that I have to apply tan alpha. I have to find tan alpha. So tan alpha is equal to 36 opposite over adjacent, 96 root 3. Right, so tan alpha will be equal to, if you divide 36 by 96 root 3, 36 divided by 96 root 3. So for this you have to divide. Okay, you have to divide 36 divided by 96. Okay, but 96 you have to multiply by 1.732 first. Okay, so 96 multiplied by 1.732, you will get an answer. Okay, you will get it as multiplied by 1.732. It will be equal to 106. Okay, have to multiply. 6 times 2 is 12, 6 times 3 is 18, 19, 1 here. 6 times 7 is 42. 6 times 7 is 42. 6 times 7 is 42. 12, 9 times 6 is 18, 19. 6 times 7 is 42. Here 43, 4 is here. 6 times 1 is 6. So 10 here. So 9 times 2 is 18. 9 times 2 is 18. 1 here again. 9 times 3 is 27. 28. 9 times 7 is 64. 9 times 7 is 60. 54, 63, 65. So here 65. 6 is here. 9 times 1 is 9. At 6, so it is going to be 15. So 2 here is going to be 17. So here 12. Here 6, here 6, here 1. Right, we got the answer. What is it? It is 166.272. 166.272. What is this? This is 1.732 multiplied by 96. That is 166. Okay, now what we have to do? We have to divide 36 by this. We have to divide 36 by 166.272. Okay, we can't divide. So what we are going to do? I'm going to put two zeros. And for now, what I'm going to do is I'm going to round it off and take 166. This as 166. So I'm going to omit these values. Okay. So now I'm going to find this. So how many 166 in 360s? You have one. So you have 2, because 150 is going to be 300. So you have 2 here. So 2 times 6 is 12. Okay, so 2 times 6 is 12, 2 times 6 is 12, 13, 1, 2 times 1 is 2, here 3, 332. You have 332. Okay, so you have remaining 28, 200, and you take the 0 here. It's going to be 280. Into 8 you have only 1. So here 1 times is 166. You get a balance of here 4, here it is 7, here 1, so 140. 140. So you don't have it, I don't know, you have here 4, here it is 7, you take 1 to 1, here 100, 1140, you have 666, so 21.6 is enough, 21.6 is enough. So this will be equal to since this is a tan angle, you have to find another for another digit, and 144 you have 6 times 166, 6 times 166 will be equal to 996. So if you subtract 996 with 140, it will be equal to here you have 4, here you have 4, you have 1 here, yeah, here 4, here you have 3, 13, 14, here again you minus 1, okay, again 140, so again you have 6, okay, so the answer is going to be 2166. So if 3600 is multiplied by 100 and divided by 100, okay, this 36, what I did was I found this value, that is 166 part, and I would divide that by 36, but 36 I can divide by 166 because 36 is lesser than 166. So I made 36 to 3600. For that I multiply by 100. So this is 3600. I divide it by 166. So this value should be equal to what? 21.6. So here in my answer I still have this 100. So 21.66 divided by 100, this will be equal to 0.2166, okay, 2166. So if you take the tan value, you will get alpha is equal to 12 degrees from the table. You can look at 36 minutes, 36 minutes, okay, 36 minutes, fine, right. So that is the angle, so I don't want this part, okay, and this triangle, do I want it? Do I need it? Okay, I'll keep this for your reference. Okay, this triangle is for your reference. Okay, this triangle is for your reference, fine. Okay, so you found the angle, and you found the velocity, right? Okay, now let's move on to the next question. Okay, so the thing that I have to tell you all is okay, fine, this, okay, right. Let's take a page here. Okay, I need a page, add page, template, this is the blank page. Okay, great. Okay, this page, why is this in white color? This is too bright. Great. Okay, fine, I take white color. So okay, on this Monday, I guess, Monday, is it Monday? It is Friday, ne? It was Friday, I guess. It was Friday. On this Friday කියන්නේ, Friday means it is I think it is going to be Friday is 14th, 14th, yesterday, 14th. So 14th of August. Okay, what is this date? This is 2026 A-level batch physics paper day, MCQ day. So they face the essay and structured on this Monday. This is Friday. This is Friday. I mean, today is Saturday. So tomorrow is Sunday. So day after tomorrow, Monday. Monday they have the essay paper. Okay, in 2 days. So people, the announcement is that in the history of physics papers, the hardest paper was on 2015. The hardest paper was on 2015. The 2015 A-level physics paper was the hardest in the entire history of A-level physics. So after this is all syllabus. So after this was due to, the reason was the crew which made the 2015 paper was in the crew, the head, I mean there's a head for the crew, for the paper crew. The head was from a max department. Okay, max department. So they had a lot of max stuff in the 2015 paper. So after this, 2016 was a normal paper, 17 was a normal paper, 18 was a normal paper, and suddenly the syllabus changed. And with the change of the syllabus, I guess in 2019 you had the next hardest paper, and it was not hard as much as 2015. Okay, I think this was in the new syllabus, all syllabus age of new syllabus and all syllabus. Okay, in the transforming age. Okay, this was also some reason, I don't know the reason why the 2018 paper got a little bit harder. And this year we made a history, what 2026 paper got the third rank to be the hardest. Okay, it is the new syllabus, it is from the new syllabus. So the most hardest paper in this entire history goes to 2015 gold rank. Okay, it has a gold rank, first place. It is that hard. If you go and look into the 25th question in 2015, you will be damn upset. It is that much harder. And the next hardest paper is in 2019. Okay, it's a little bit hard. Okay, it is so hard, not as 2015, because it is the most hard. So the second rank goes to 2019. Then the third rank now has been gone to, this bronze medal goes to 2026. There was no any hard papers in this history more than this and this. Okay, because these two were the hardest in until 2026 paper was released. But suddenly this 2026 paper changed everything, people, everything. Okay, everything. So now what I have got to say is, study hard. The 2026 badge is a history making badge, because the paper was so damn hard. It was so hard that majority of students says the structure of the paper was entirely different from the past papers. Okay, it was entirely different. People think that you practiced, okay, just think like this, will you practice a lot of past papers, a ton of past papers, and you sit on the exam day, and that exam day paper is going to be an entirely different paper. Okay, what you're going to do, you're going to be upset, you're going to be totally upset. But thing is, if you focus only on past papers, your situation is going to be null. You would be really upset. So what I'm trying to say is, do not only focus on past papers. Okay, you all didn't start to do papers, ne? You all didn't start to do past papers, ne? So still you have time. You have to do all questions. You have to do all questions that you get. Okay, and the main part about the 2026 batch is they are the batch with the shortest time period. They had the shortest time period, people. They had the shortest time period to get ready. Okay, if you take an average AL badge, this 2026 badge had the average batch had 3 months more than the 2026 batch. So it had only, I guess, you normally have 2 years and 3 months, right? So it has 2 years. This has 2 years and 3 months, I guess. Okay, 3 months. So this had the shortest time period and had the hardest paper and in the shortest time. So this batch is going to make history. Okay, so the next history should be your batch, understand? So 2027, your batch is 2027, right? So 2027 people, now try to do your best by doing many questions as possible. Search question in every places. Okay, you have many questions these days. Actually, you can make questions by using AI technology, right? So this is the interesting part that I found on these days, and I don't know people what to say. Okay, that page is really power. Okay, really power, because they had no time and the hardest paper. But that is fine, because the Z score is that's an evaluation related to progress with the average person. So when everybody's getting lower marks, our marks is going to be okay. That is okay. So be happy, not sad. Okay, don't be sad, be happy. Okay, fine. Right, and the next announcement I had to give is today is Saturday. Yeah, today is Saturday. Okay, tomorrow is Sunday, and the next Saturday and the next Sunday. Okay, these classes, this is going to be a recorded class. This is also going to be a recorded class. This is recorded and this is recorded until my exam gets over. So this is Saturday, this is Sunday. Okay, these are going to be a recorded class, so stick to the plan. Okay, stick to the plan, because the thing is, you have to get practice to whatever the class that is. So in Ratnapura, basically there are a few number of physical classes, physics classes. Okay, physics English medium classes. So you have to practice your, so the reason is the number of people who are studying, in English medium is really low. So therefore nobody is going to conduct classes, because there's no crowd. So when there's limited number of classes, what you have to do is you have to be focusing very carefully. Okay, focusing very carefully, because the thing is, you have only limited classes, the choice is little low, so you have to stick to what you have. Okay, stick to what you have before trying other things. So since I'm getting online classes, don't think this is online class, I'm searching for a physical class, and just don't skip classes. Okay, online class, I don't like online class, I'm going to stay at home. Okay, not going to class. No, don't do that. I'm not going to watch recordings. No, you have to understand, this is the most competitive exam in Sri Lanka. The most competitive exam in Sri Lanka. You can't never compare yourself with only an English medium student. You have to compare yourself with a Sinhala medium student. So my target is to make a good rank from A levels, from your batch. Okay, so stick to my plan and see that I'm going to keep recorded classes these weeks until my exams finish. So stick to my plan and do everything what I say. Okay, because I'm an high achiever. I have achieved a good rank and I have entered engineering faculty and I'm studying these days. So you have to also follow a plan, the footpath of a successful person without going in an average person's life. Okay, so that's why I'm every time just giving a small motivation to you all to work. Okay, so stick to the plan and start doing your work with a good bang boost. Okay, with a good bang boost. Okay, right. Now let's continue to the next part. Okay, right. So now we are going to move to the 13th solve exercise. 13th solve exercise. Right, 13th solve exercise. Right. So what is the, let's read the question and let's see what they are asking. Okay. Find the velocity. Okay, again we have to find the velocity and the direction of motion. Direction of motion. We have to find the direction of motion. What? The velocity and the angle. At vertical height 497 r. Now first of all they gave time. Now they are giving what? They are giving the distance, the height of a bullet, height of 96 of a bullet fired by a cannon. A bullet fired by these are not relevant. Okay, what? Bullet or ball or everything is fine, everything is same. Cannon with a velocity of 1024 meters per second, this height making an angle of 30 degrees. Okay, this is the projected angle. We have to find the final angle. Sorry, we have to find the final angle. Okay, now let's start to do this question. You have every data here in this figure. You have every data. Now what you have to do, slowly start to write the question. Okay, fine. Now what's the first step? First step is to find the the okay, first step is to find the what, horizontal and vertical velocities. Right, let's find it. So first of all we have to find the u1. Okay, u1. What is u1? u1 is in the horizontal direction. That is going to be what? The main velocity cos 30. 1024 cos 30. Cos 30. So cos 30 in the sense it is going to be root 3 over 2 multiplied by 1024. This is going to be divided by 2. So this is going to be 1024 is going to be 512. So this is going to be 512 root 3. 512 root 3 meters per second. Fine. Found u1. Now what we are going to do, we are going to find u2. That is in this direction. u2 is in this direction. This is going to be that 1024 multiplied by sine 30. This is cos 30 sine 30 with the angle what? With the 30 degrees with the horizontal. This is the horizontal. With this horizontal you are making this angle. Understand? So that this is going to be cos 30. This you don't have an angle. That angle is with this part. So this part doesn't has an angle. This is the only part that has an angle. So this part doesn't has an angle here. So it is going to be sine 30. Sine this angle. Sine this 30 angle. Okay, that's the only what explanation. So 1024 sine 30. So this will be equal to, so sine 30 is equal to what? 1024. I said cos 60. What? Cos 60 equal to sine 30. This two should be what? Sorry. Yeah. These two should be what? Add up to become 90. Now right. So cos 60 is equal to half. So sine 30 is equal to half. Understand? Okay. Right. So here if you are going to do 124 divided by 102, this to cancel off by divided by 512. So this is going to be 512. So it's better if I can erase this part and take this man copy, and I can paste it here and drag it to here. Oh my god, yes, okay, 512, this and this meters per second. Okay, I found the what velocities, right? That's all. I'm going to draw a line. Okay, right. What I'm going to do, I'm going to find the velocities. So the what the right the this velocity is going not to what the horizontal velocity is not going to change. Okay, the horizontal velocity, okay, these parts. Now let's erase this stuff. Let's erase this. We don't want this. Okay, we don't want this. Okay, right. So the horizontal velocity here is not going to change. It's not going to change, right? This is not going to change. The horizontal velocity here is not gonna change. Why? The horizontal velocity is not gonna change. Why? The statement that we wrote above. Yeah. Why? The horizontal velocity here. Since the horizontal velocity is kept constant throughout the entire motion in the projectile, why it's not going to change? Because there's no any unbalanced force. We wrote it here. In the horizontal part of the inclined motion, the acceleration is zero. So if it is better if you can write this point also. Why? Okay, so this will be equal to what we are going to do. So therefore the horizontal velocity is constant in the entire motion. Yeah, the horizontal velocity is constant in the entire motion. Okay, right. So let's move on to here. Okay, right. Let's move on to here. Here. So okay, here. So the u1 here is not gonna change. We have to find only u2. u2 is the vertical part. So to find vertical stuffs, we have to apply vertical motion equations, right? So I'm going to name here as A. Okay, mark these stuffs A, and here as point B. Now I'm going to apply from A to B. In which direction? Up direction. Okay, up direction. The initial velocity is u2. It is how much? 512. And the final velocity, we should know the final velocity, that is going to be v2. We are going to find v2. We know the v1. V1 is equal to vu1. Why? The horizontal velocities are same. And what are the things that we know? From here to here, we know the vertical height. The vertical height is 496. In the first question, they have given the time. The time was 6 seconds in the first question. Here, what they have given is they have given the distance from here to here, the height. So that height, we are applying the vertical motion. So the height traveled from here to point here is 496. Okay, right, we can apply that. So that is 496. Okay, that's the next data that we have. Every time we have the acceleration, that is -10. By -10, we are applying to the up towards we are applying this towards the upward direction. So we know the velocity, we know v, u, s and a. The equation is going to be v squared part. So I'm going to apply that. So v squared equal u squared plus 2as. So final velocity is v2 squared. That will be equal to 512. Okay, I'll zoom it a little bit. 512 squared. Okay, squared plus. So since this is minus, since the acceleration is minus, it is going to be minus here. I'll put it right here because a is minus. So 2 times 10 times the displacement, that is 496. So this will be equal to some value that is going to be so 512 square. So okay, let's write it here. 512. Okay, 2 times 2 is 4, 2 times 1 is 2, 2 times 5 is 10, 1 times 2 is 2, 1 times 1 is 1, 1 times 5 is 5. Okay, 5 times 5 12. 5 times 5 is 5 times 5, 5 times 2 is 10, 5 times 1 is 5, here 6, 5 times 5 is 25. Okay, let's add up. 4, here 4, here 1, here 12, here 1, here 6, here 2. Okay, this much big answer. Okay, here it will be 2 6 7 comma 1 4 4 minus, here what you have, 496 multiplied by 20, multiply by 20, 0 0 0 0, multiply this. So 2 times 496, 2 times 6 is 12, 2 times 9 is 18, here 19, 2 times 4 is 8, here 9. Okay, 2 times 5 is 8, here 9, 0 2 9 and 9, 9 9 9 9 2 0. So we have to subtract 2 6 7 comma 1 4 4, subtract 9 9 2 0. So this is 4, 4 subtract 2 is going to be 2, here 11, 11 subtract 9 is 2, here 6, 6 subtract, you can't subtract, take 1, and 16 subtract 9 is going to be 7, here 5, here 2. So this is going to be 257 like this. So let's find the square root of 257224. Alright, so if you find the square root of this, did we do anything wrong? Okay, did we do anything wrong? Okay, if I want to subtract 20 multiplied by 496 is equal to this much, and square root of this, or square root of this. And 5, and here so this, and we're going to put a power to 1 divided by 2, and this will be equal to okay, so let's see, 512 divided by 512 is equal to 26214. Oh, this is correct. Okay, and the next part, 496 multiplied by 20, that is equal to 9920. Oh, 9920, fine. So we have to subtract 267 144, 267 144, subtract 9920, that is equal to 257224. Okay, let's take the square root of this. Okay, square root of this, square root of 257 224. What? Okay, fine. So this is almost, okay, this is almost this value. Where is it? Where's the pen? Okay, so this is equal to square root of this. Square root of this is equal to should not take the square. So v2 is equal to how much? 257,224. 257,224. Okay, 257,224. Right. Okay, so we have to find v2. v2 is square root of 257,224, and if you use logarithm tables, you have to use logarithm tables to find the square root. You have to take half, multiply by log to find this part. Okay, so then you will get this is equal to square root of this, square root of 257,224 is equal to something. It's almost 100, 502. Okay, if you round it off, it is going to be 502 meters per second. 502 meters per second. So we don't want this part. We can erase this whole stuff. Okay, Okay, you can take this. So we found the v2 velocity, right? We found the v2 velocity. Okay, right. So after that, the same steps we're going to do. We are going to do the same steps. We are going to find the what main velocity, okay. I'll erase every part here, okay. We are going to find the main velocity. So we know that for this we have to draw the diagram. This one and this one and this part, okay. So this is going to be v1, this is going to be v2, and this is going to be v, okay. This is going to be v, and this is going to be alpha. So I draw this certain small drawing. I'm going to draw this small drawing. So I'll separate this drawing here, okay. So I'm going to draw this. So here, to find this v, I'm going to take the square root of v2 squared plus v1 squared, square of this 2 and square root of this, okay, square root of this. So if I take the square root of this, this will be equal to v1, v2 is equal to 502 square of 502 plus v1 is equal to u1. So what is u1? u1 is 512 root 3, that is u1, that is v1. So v1, that will be equal to, we have to find that also here, we have to find this. So 512 multiplied by 1.732. So I am going to multiply 1.732 multiplied by 512, okay. 512, 2 times 2 is 4, 2 times 3 is 6, 2 times 7 is 14, 1, 2 times 1 is 2, here 3, okay. Here 1 times everything, so 2, 3, 7, 1, and then I have I don't have space here, so I'll move this whole part somewhere here, okay, fine. So now I can do this. So then 5 times part, okay. 5 times 2 is 10, here 1, 5 times 3 is 15, here 16, okay. 5 times 7 is 35, 36 here. 5 times 1 is 5, so 5 plus here 8. So 4, 6, 2 is 8, 4, 3 is 7, 7, 6 here, took 1 here, 14, 15, 16 here, 6, 7, 8 here, 8 here. So the value is going to be like this. This will be if you multiply this will be equal to you have how many decimal places? 3 decimal places. So 512 multiplied by root 3 will be equal to how much? 886.7 something. So what I'm going to do, I'm going to round off this to the whole number, okay. So this is going to be 887 meters per second, 7 meters per second. So I'm going to write that value here, 887 square, okay, 887 square, and the square root of this, So now what I have to do is I have to square this and I'll draw this diagram here. Okay, I'll draw this here. Okay, fine. So this will be equal to 502 square, okay, 502 square. So you have to do these questions, you have to do these calculations. If not, you are going to be in trouble. If you didn't practice it here, you are going to be in trouble. You have to take a small scratch paper and do everything. Okay, now I'm going to find square of 502, okay. 502, okay, 502, okay, 502. So 2 times 502, is going to be 1000. Okay, I'll put this to here. Who put it here? Okay, this is 2 times 502 is going to be 502 plus 502, 1004, 1004. 0 times this is going to be 0, 3 digits, so zeros, okay. Now I'm going to start from here. So I just put a line for my organizement. So 5 times 2 is 10, 5 times 0, 0 plus 1, 1, 5 times 5 is 25, okay. 4, 0 0 2 5 2. Okay, this is the 50 title 502. Okay, fine. So what's the next one? 886, square of 886, square of 886, 887, sorry, 887, 887, square this. Okay, most probably this will be going in the way here, from here to here, so I'll use this. 7 times 7, 49. 7 times 7 times 8, that is going to be 56. So 56, this is 60. 7 times 8, again 56. 56 plus this is going to be 62. 62. Okay. 56 plus 6 is 62. Okay. 8 times 7, again 56. Here 5. 8 times 8 is 8 times 8 is going to be 64. 5, 69. Okay. 8 times 8 is again 64. 64 plus 70. 64 plus 10 is 70. Okay, right. So I'm going to put a line here. Okay, if not I will confuse everything. 8 times 7 again 8 times 7, 8 times 86 is this. So again 8 times this is going to be 6, 9, 0 and 7. Okay, right. 9 here, 6 here, 9 plus 2, 9 plus 66 is going to be 15, 15, 16, 17, 17, 1 here. 9 plus 1 is 10, take this 6, 60. 7 here, 8 here, 7. Okay, so here this is going to be this value and this is going to be this value. So here what I'm going to do, I have to add these two. So I'm going to write 2 5 2 and 0 0 4. Here final 3 digits I'm going to write all together, and the next 3 digits I'm going to write 786. 786. Okay, add these two. 9 plus 4, 13. 6 plus 1, 7. 7 again. Here 6 plus 2, it is 8. 8 plus 5, 9, 10, 13. Here 1. Here 10. Okay, here this is the value. So this is the value. You have to take the square root of this. Square root of this. Okay, square root of this. So I will write it down here. Copy, and here paste, and I'll write it here. Okay, this is the final value. So here I will erase this whole stuff. I don't want this. If you want, you can take a screenshot and do your rest of the parts. Okay, so I found this, and this will be 90, 90, 90. Okay, we have to take the square root. And the answer will be, we will be almost 1019 meters per second. If you find the logarithm part, you will find this. Okay, we found one of the main factors. We found the velocity. Okay, we found the velocity. Okay. Okay, we found one part. Now what's the part that we have to find? It is the angle, the direction. So I'm going to find the direction. Okay, right. So the way to find the direction is opposite over adjacent. That is going to be tan alpha. So I'm going to write it here. Sorry, tan alpha is equal to v2 over v1. That is, v2 is equal to 502. v1 is equal to 5 and 12 over root 3. Okay, 887. This is, if you divide this by this, you will get you have to divide. So 502, I'll put as extra 0 and divide this by 887. So in 502 you don't have. Again in 5020, 887. In 1000 you have 1, in 1000 you have 1, in 2000 you have 2, in 5000 you have 5, and here you get remaining from 1000, like if you subtract 887 from 1000, you will be remaining like 100 something. So 100, and let's take it as 120. So 520s, if you add them together, it will be 600. So 600, it can't make 800. So there will be only 5 800s, 5 800. So if you multiply this 5 times 7 is 35 here, 35, 5 times 8 is 40, 43, 5 times 8 is 40, again 44, 435. So here you have 5, you have 11, 11 minus 3 is going to be 8. So here you have 9 minus 4 is going to be 5. So 585 now, you have 585 now. So 585 like this. So in 435 you have remaining to make 5000 from 400,000, from 4435 to make 5000, to make 5000 you have like here 600, so 500 something. So 500 something add to 800, you will be, you have another 800 here, another 800 here, so it will be like 6 800. Right here you have 800 something, to make 887 you need another 37. That 37 is inside this to this one's gap. From 435 to 5000 you have small gap. In from that gap you can take the 87 part, you can take that exam. So surely you will have 6 parts, I mean you have 6 887s in here. Okay, fine. So now I have to multiply this. What? 6 times 7, 6 times 7 is 42, 42. 6 times 8 is 48, plus 2 is going to be 50, 50. 6 times 8 is again 48, 48 plus 5 is going to be 53, 53, 53. You got it, right. Yep. So here you have to subtract again, and 10 minus 2 8, here 4, here 8 minus 3 is going to be 5. Okay, 8 and 5, 5408, right? Yeah. So again 5408. So here you got 5300 something. So you put a 0, again you have 6, again you have 6 until 5302. Okay, so here you have added like 100 some hundreds to this 502. So again you have, still you have 6 parts, and it will be again be 302. Again when you subtract this, you will get 302 to 400, you have 98, 98 plus 80, 80 plus 80, 160, 160, 178, 178. Okay, in 1780, I think you have 2887. So this is going to be the value, so this part until 4 digits you have to find, because this is a tangent, okay. So you put a 0 here, so so to compensate that, you have to take this digit here, this decimal point here. So this will be 0.5662 something, 662 something. So here you will be 2 times 7 is 14 here, 2 times 8 is 16, 17 here, 2 times 8 is 16, again 17 here, 74, you remain 60. In 60 you don't have anything, so here 0. So this is a good decimal tangent. So you have to find alpha is equal to tan inverse 0.5662. So alpha is equal to tan inverse something. So take your logbooks and find tan inverse 0.5662. 5662. Okay, right. That will be how much? That is 20. Well, how much? 29 degrees 31 minutes. Okay, 31 minutes and 6 point something seconds. So 31 minutes. So this is the final answer. Okay, now it's almost 2 hours. 2 hours past. 2 hours past. 30 minutes. Okay, right. Take a small break and let's continue the other parts. Okay, so we found the angle. Okay, we found the angle. Now let's erase everything. Okay, right. Now you should be able to understand this. Right. Now let's move on to the next question. It is the 14th question. Right. 14th question. So so here we have to find the maximum height reached and the horizontal range and velocity and direction of motion 8 seconds after the projection. 8 seconds after the projection. Okay, what we have to find? The velocity and the direction, okay, of the motion after 8 seconds of an object with a velocity of this and inclined by an angle this, okay, to the horizontal this. Okay, so this is Roman number 1. We have to find this is Roman number 2 and this is Roman number 3. Okay, now let's draw the plan for this. Let's draw the plan for this question. Okay, right. So first of all we have to find the maximum height. We have to find the maximum height reached. Okay, then we have to find the horizontal range. Okay, so then we have to find the velocity and the direction of motion. Velocity and the direction of the motion. Right. So first of all, have to find the let's rank this as 1. Sorry, this as 1, this as 2, and this as 3. Okay. First, we can find the maximum height. How we are going to find the maximum height? We are going to apply motion equations to the vertical part. Okay, vertical part. Okay. Before everything else, what is the first part? First part is to find horizontal and vertical components. Okay, u1 and u2. Okay, u1 and u2. So u1 and u2 we have to find 80 cos theta and 80 sin theta. But do they have given the angle here? No, they have not given the angle. They have given that tan inverse theta is equal to tan inverse 4/4/3. So for this we have to find this angle first and then u1 u theta. Okay, now let's again write this. We have to find theta, then u1, then u2. Okay, we found them. Third, we have to find the maximum height. So to find the maximum height, we are going to apply u squared over 2g. How did we come to that u squared over 2g? We applied v squared equal u squared plus 2as. For that, we did the velocity, final velocity at this time, that is 0, we know that. Initial velocity, we know that. And g, we know that. And s from here, and s is the height. That's the height. So we are going to find hm next, maximum height. Okay, we can find. Then third, we have to find let's name it as a, this as b, this as b, this is a, b, and this is c. Okay, this is a, this is b, and this is c. So to find b, I mean the horizontal range, we have to apply s equal ut to this direction. So to find s, we should know u and we should know t. So u is going to be this velocity, the horizontal velocity. So we can find that by u1, that is going to be this one cos theta, Okay, now we have u here, and we want t. What is t? T is going to be the time of flight from here to here. Time of flight. So before finding the range in horizontal direction, we have to find the time of flight. So the next target is to find time of flight. Then what we have to find? Then we have to find the range. Okay, from that we can apply the motion equations and find the range. Understand? All right. So after that Then we have to find the velocity. Okay, which velocity we have to find? This particular velocity after 8 seconds. After 8 seconds. So we have to apply in this direction. Do we have to apply? No. Why? At this point we have two velocities. We have two velocities, one in horizontal direction and one in vertical direction. But in this case the ball is moving towards the ground, so one in this direction and one in downwards direction. Okay, so to find this velocity, we know that from this vertical horizontal velocity doesn't change, it is constant throughout the whole motion. I said that. So this is constant throughout the whole motion from here to here. So v1, we know v1, that is this, but v2 in this direction we doesn't know this v2. So to find v2 we know the initial velocity, we want to find the final velocity, we know the time gap, and we know the gravitational acceleration. So we know v, we know u, t and a. So we can apply for the vertical direction v equal u plus at and find the v2. We can find the v2. Understand? So we found the v1, we found the v2, and by using this law we can find the resultant one. We can find the resultant velocity, that is rp, or we can call it as v. Okay, let's take it as v. Okay, so this v we found that v, okay, by v1 squared plus v2 squared square root by using Pythagoras. Okay, by using this velocity here, this velocity in this direction, this velocity in this direction, and the resultant from the third side, that is will be in this term, that is v, capital V. That will be equal to this one squared, this side squared, plus this side Pythagoras law square root. So we can take v1 squared plus v2 squared square root. Understand? We can take the square root. Okay, so no worries, we can find this v2. We know this v1, we can find v2. So the next target is to find v2 by applying motion equations. So after that, what we have to do, we know this, we drew the triangle from here to here, it is v1, from here to here it is v2, this one v2, this is v1. So we have to find the resultant force, that will be here. So I'll mention it as v. And this angle theta, okay, again I'll draw the triangle. This angle theta, this is v1, this is v2. So this angle theta is this is theta, okay, this is theta. So our target is to find this theta. What theta? This is the angle. So to find the theta, we have to take the tan value of theta. So tan value will be every time equal to, we drew the triangle like this. So this is theta. So this is v2 and this is v1. So this will be opposite over adjacent. So this will be v2 divided by v1. Understand? Okay, I gave you a small summary. Now let's do everything quickly. Okay, this is our target. So what I'm going to do, I'm gonna erase this, and I'm gonna keep this small plan of mine. Okay, I'll make this as a short note to myself, and let's keep it somewhere that I can take it. Okay, I'll keep it like here. I can make this even smaller. Okay, I'll keep it here. So first of all, my target is to find this theta 1. Okay, so they have given that to find this theta 1, the easiest method is to draw a triangle. Okay, I do a triangle. Okay, so in this triangle, this is u1. Okay, this velocity, and this is u2. Which velocity? This velocity, vertical velocity. Okay, so the resultant will be given by this, that is the third side of the triangle. This is the resultant, and that is how much? That is something, okay, that is going to be the 80 meters per second, 80 meters per second. So this is the angle, and this should be the angle, and that is theta. That is theta. I'll mention it. I'll put it here. Theta. This is theta. This is theta. Okay, fine. So they say that what theta is equal to tan inverse 4 by 3, 4 over 3, 4 by 3. Okay, so I can say that tan theta is equal to 4 over 3, ne? 4 over 3. Yeah, that is correct. Why? If tan theta is 4 by 3, so theta should be tan inverse 4 by 3, ne? We did the inverse of this. Understand? We did the inverse of this. Okay, right. So from here we went to here. Tan is theta is equal to this. Right. Okay. Right. So we know this. So this is equal to, people, this is equal to opposite over adjacent. This is equal to opposite over adjacent. Understand? So 4 should represent the opposite side of the triangle, and 3 should represent the adjacent side of the triangle. Understand? So what I'm going to do, I'm going to erase this 2, and I'm going to relate this part, this opposite adjacent here. So theta's opposite side is this U2's area. So that is 4 in length, 4 units in length. So theta's adjacent part is this. So that is 3 in length, people. So what is the relationship between this hypotenuse and these two sides? This is a right angle triangle. So this is equal to 4 squared plus 3 squared square root. So you all know that this value will be equal to what? That is equal to simply that is a Pythagoras triple. So you all know the Pythagoras triple 5, 4, 3. 3 squared is 9, 4 squared is 16, 16 plus 9 is 25, square root of 25 is going to be 5. So the length of this hypotenuse is 5 units. So what this triangle say is, it is giving you an important message. What is it? If the vertical velocity, if the vertical velocity is 4 units and the horizontal velocity is 3 units, then definitely the resultant of these two velocities will be 5 times the unit. If this is 4 units, if this is 3 units, if this is 4 units, if this is 3 units, the resultant will be definitely what? Definitely 5 units. Understand? Right. So now we have this relationship. And now we can find the resultant force. Now we know this Pythagoras part. From here we can derive cos theta. Cos theta. What is cos theta, people? Cos theta is equal to adjacent over hypotenuse. So this cos theta is equal to 3 over 4, 3 over 5. And sin theta, it is equal to, people, opposite over hypotenuse. That is equal to 4 by 5. Right. So we know cos theta and we have sin theta. So the thing is, we have to find what? We found theta. Now we have to find u1 and u2. We have to find simply u1 and u2. Right. Let's find it. No problem. Okay, let's find it. So now I'm going to find theta. Now we are going to find u1 and u2. So you all know that u1 is the horizontal, so it is 80 cos theta, this is vertical, okay, vertical in the sense adjacent side cos theta, opposite side sin theta, 80 sin theta. So I'm going to write u1 is equal to 80 cos theta is equal to how much? 80 multiplied by cos theta is equal to 3 by 5. 3 by 5. Okay, 3 by 5. So this will be equal to 80 divided by 5. That is going to be 80 divided by 10 is 8. So divide by 5 in the sense you have to multiply by 2, 16. 16 times 3 is 48. This is 48 people. This is 48. So let me find the u1 also. Let me find u1 also. Let me find u1, u2 also. So u2 is people equal to 80 sin theta. 80 sin theta. So this is 80 sin theta is equal to 4 by 5. 4 by 5. So 80 I have to divide by 5. That is going to be 16. 16 multiplied by 4. That will be equal to 64. This is equal to 64. 64. The horizontal velocity is 48 meters per second. The vertical velocity is 64 meters per second. Simple. That much simple, people. This is that much simple. Okay, that much simple. So we found the which part? We found this whole part. We found this whole part. Okay, one part finished. One part finished. One part finished. Alright, now let's move on to the maximum height part. Now only we are moving to the question, right? So let's divide this to A, B, C, D. We divided this to A part, B part and C part. Now let's go on to the A section. A. Section A. Okay, whatever. A part. Move to the A part. So the A part we have to find the vertical velocity, vertical height. So we know the initial velocity. We know the initial velocity, that is u2. That is equal to u2 is equal to 64 people. Acceleration is equal to minus 10 people. So the height is equal to hm people, and then we have the then we have the final velocity here. That is going to be 0. That is going to be 0. Final velocity is equal to 0 people. That's all. So B, U and S. This is S. Sorry. This is S. Okay. Now what's the equation? We are going to apply the equation from A point, B point and C point. We are going to apply this from A to B. Okay. So the motion equation, upwards v squared equal u squared plus 2as. The final velocity is 0. Initial velocity is 64 and it is squared here negative 10. So here negative 2 times 10, and the displacement is h. Okay, I'll take it as h, not hm. Okay, if I take hm, that's towards h. So here, as every time, I'm going to take this 20h here, keep this 64 squared here. So 64 times 64, 4 times 4 is 16, 4 times 6 is 24, 25. 6 times 4 is 24 again, 6 times 6 is 36, there's 38. So this will be equal to 6,901,4096. In the sense 2048 is double, that means 1024 is good. Okay, this is correct. So this is going to be 4096. So h is equal to people 4096 divided by 2 is equal to 2048. That one we have to give a decimal because 20. So this is going to be 204.8 meters. Maximum height is going to be 24.8 meters. Okay, fine people. That's all. So very easy. Okay, now I'm going to find the, now what's I have to find the range. I have to find the range. One part is finished. One part is finished. The next I have to find the range. For that I have to find the time of flight. So let's go move on to the second part. Let's move on to the second part. Okay, right. B, let's move on to B. So B, what is B? We have to find the time of flight. So time of flight, initial velocity is 64. Acceleration is -10. Since we are applying this for up, the distance we don't know. It is coming back to the initial position. So the displacement is 0. Y again coming to the same level. Okay, I said it before. And the what is it? What's the next one? And the next one is U, A, S, and time. We have to find the T. It is going to be capital T. Okay, I'll put this capital T. Fine. Now U, A, S, T is equal U T plus half A T square. So we are applying this from A to C. Why we are applying this from A to C? Because it is the horizontal part, because from a horizontal part but we are applying this for the whole motion. We are applying this to the whole motion. Right, now let's see. We're going to apply S equal U plus half A square. So let's start from here. S equals ut plus half at squared. The displacement is 0, initial velocity is 64, time capital T, since this is negative a minus half a is equal to 10 and time is equal to t square. Okay, t square. So we come up to the same previous equation, this to this 5. So 5t squared is equal to 64t. Okay, since capital T is greater than 0, we can cancel this to this to this. So capital T is equal to 64 divided by 5. So this cancelling part, I never like to write it like this. I never like to cancel this part because they don't give marks for cancelling. If you don't mention what you cancel, then also they will give the marks. Okay. Because in answer scheme that is made by the professors, they don't cancel those stuffs. Okay, so 64 divided by 5, that will be equal to, this will be equal to, this will be equal to, this will be equal to, sorry, this will be equal to how much? 64 multiplied by 2. This is going to be 64 multiplied by 2, 5 multiplied by 2 to make this a 10. So 65 128 divided by 10, this will be 12.8 seconds. 12.8 seconds. This just only take 12.8 seconds. Let's take only 12.8 seconds. Fine. Right. So this is the time of flight. This is the time of flight. So this is a little bit big. I have a big space. So let me make it smaller. Okay. Smaller. So now I can catch everything together and make everything smaller. Okay. Okay. Right. So I'm doing this tuition, this recording in my hostel, right? So my friends come here and take some stuff because the exam is here. So people come here and take pens and stuff. So this is life of university. You have the freedom to meet your friends the whole weekend, whole week. Right, let's move on to our work. Right. So we found the time of flight. It is 12.8 seconds. So still we are in this question, in this particular question. Okay. Suddenly this has let's do this part. We have B part and we have the C in it. Okay, let's divide this here. The next part is to find the velocities. Okay, velocities. Let's divide this here from here. Okay, now we are going to find the next part. Okay, we don't want that. Okay, now we have the time, and we are going to apply motion equations. We applied this in the vertical direction, so now we are going to apply motion equations. In which direction? In horizontal direction. Why? We are going to find the range. We have to find the range. So we are going to apply the motion equation. Before that, let's mention what do we have. We have the initial velocity, horizontal velocity, that is equal to how much? u1 is equal to 48 people. Okay, u1 is equal to 48, and we have acceleration that is equal to 0. While in horizontal motion you don't have acceleration, so u and time, the time is equal to 12.8 seconds, and what we have to find is the displacement, that is equal to the range. So we apply motion equation. S is equal to ut. So S is equal to r, u is equal to 48, and time period is equal to 12. So let's write it here. Time period is equal to 12.8 seconds. So 48 multiplied by 12.8, 128, 48. 8 times 8 is 64. 8 times 2 is 16, 17, 18, 19, 20, 21, 22, 22. 8 times 1 is 8, 9, 10. So here 4 times is going to be the half of this. So 4, 4, 1, 6, 6, 1, 4, 4. 6,144. But here you have a decimal point. You have a decimal. And the range is going to be, not seconds. It is going to be meters. The range is equal to 614.4 meters. Okay, this much. Okay, all right. We found the range. And this is from A to C. This is from A to C. We have to mention that also. Okay, let's take it up a little below. All right. This is from A to C. Okay, so let's write a small line here. Good. Okay, fine. Now let's move on to the C part. Yeah, let's move on to the part C. Okay, C. Right. What's our target? The target is to find, but we finish this. Okay, right. We finished this time and range. We finished this. Now we have to find the V2. What is V2? V2 is going to be after 8 seconds. People. Right. Now to find this V here, to find the velocity here, okay, to find this velocity, we have to know this V2 and this V1. Okay, so we know that this V1 is equal to this U1. Why? It is the horizontal velocity. It doesn't change. Okay, it doesn't change. So we have to just find this V2. How to find this V2? We have to apply motion equations for how many seconds? They have said 8 seconds. 8 seconds, right? 8 seconds. So no worries. We have the time, so we can find it. Okay, so what are the variables that we will know? We're going to find V. So we have the initial velocity, that is u2, upwards u2, and it is equal to, I guess, 64. We have A is equal to -10. We are applying towards upward motion, and we have time that is equal to 8 seconds, and we need something. What do we need? We need the velocity. We need the velocity, and right is v. Okay, no, it is v. v2, I guess. v2, right. What is the equation? V equal u plus 80, equal u plus 80. In which direction? Which direction? Towards up. Towards up. From where to where? From A to, not C. Now that's the third boundary. It is D. We mentioned it as D. From A to D. So let's write it as from A to D. From A to D. Right. Okay. So we are applying V equal U plus A T. So V2 is equal to U64. This is minus because negative G. 10 multiplied by time is 8. So this is equal to negative something. Why negative? Here see. So this will be equal to, okay, this is equal to 64 minus 10 times 8 is 80. 10 times it is 80. So this will be equal to 80 minus 64 is equal to 16. So negative is here, positive is here. So this is negative 16 meters per second. So here people, you have to understand this. We applied the equation in this direction, upward direction. So we thought that V2 will be in this direction, but V2 is negative in this upwards direction. Negative in upward direction in the sense it will be positive in downwards direction. So this is a velocity that is in the downwards direction. Yeah, true, that is true. Why? At the 8th second, the particle is coming downwards. So V is in downwards direction, not upwards direction. Right. So that's why we got 16. So now we are going to draw the diagram here. Okay. Right. This is V1. This is V2. So V1 and V2. Okay. This is how much is this? It is constant. U1 is equal to V1. So that is 48. This is 48. This is equal to 16. So the final value will be equal to this is final value will be equal to V is equal to, so let's keep a small space and write it here. Okay, this color, V is equal to 48 squared plus 16 squared. Why? That's because so when we write this, we have to put an angle, that is alpha. Okay, so V will be equal to how much? We have to calculate that. 48 and 16. 48 multiplied by 48 is divided by 4. 12 times 4. 16 is 4 times 4. So if we take 4 out of it, there is 12 and 4. Okay, again we can write 4. Okay, we can take 16 from both sides. We can take 16 from both sides. Wait, that is good. That's good. Okay, let's take 16 from here. 16 if we take from 48, that is going to be 16 squared. 48 is going to be 3 squared, and if we take 16, this is going to be 1 squared. So here we will get 16's square root. Outside is 16. 3 squared is 9 plus 1 is 10. 16 root 10. 16 root 10. So root 10 is people equal to I haven't given the value, but you should know the value. It is root 2 times root 5. So it is 3.162. 3.162. Okay, 3.162. Fine. So find the value for 3.162. 3.162 multiplied by 60. Multiply by 60. 6 times 2, 12. 6 times 6, 36, 37. 6 times 1, 6, 7, 8, 9. 6 times 3, 18, I guess. Yeah. 2, 6, 1, 3. 2, 9, 15, 1, 10, 1, 5. So this is equal to 3 decimal place, 50.592. So let's take it as 51. So velocity is equal to 51 meters per second. 51 meters per second. Now fine. 51 meters per second. Right. 51 meters per second. If not, this let's round off to the first decimal point. 50.6. It is 50.6 meters per second. Okay, we found the velocity, and the next part we have to find is the angle. Okay, what to do? We don't have space, eh? What shall we do here? Okay, let's use this space. Let us use this space. Okay, let's use this space. So that space we are going to find tan alpha. It is equal to tan alpha is equal to 16 divided by 48. 16 divided by 48. 16 divided by 48. 16 divided by 48. Okay, let's write it here. 16 divided by 48. 16 divided by 48. So 16 and 48, if you take the relationship between 16 and 48, it is, you have 3 16s in 48. 3 16 in 48. So tan alpha is equal to this. So alpha is equal to tan inverse 1 over 3. So 1 over 3 in the sense that will be let's move this step outside, delete, and let's move this step here because we are out of space. Okay, so alpha is equal to 1 over 3, tan inverse 1 over 3. So 1 over 3 is 0.33333. So tan inverse 0.3333. 3333. Okay, let's find tan inverse 0.3333. It is equal to 18 point something. Okay, let's, if I take the point value, I mean in degrees and minutes, alpha is equal to 18 degrees and 26 minutes. 18 degrees and 26 minutes. Right, we found the angle. So alpha is equal to this. So here, okay, draw that line. So let's draw it in another color. What is it? Is it good? Do we have a vibrant color here? Green. Okay, that is here. All right, the angle is here. Direction. Okay, direction is here. Okay, all right. So now let's move on to this exercise 50. So what did we do? We drew the plan, we found everything, and finally we found this velocity. Okay, velocity. So this is the answer. Okay, fine. Now let's move on to the 15th question. So this is a simple question. You have the diagram. So this is a very simple question. Let's read it. Okay. An object is projected horizontally. From a mountain cliff. This is a mountain like this. Para mountain. Like this. Okay, a big mountain. Okay, big mountain. This is Marina Trench. This is Everest. Okay, all right, whatever. So height 125. The height is 125 with a velocity of 100 meters per second. Height 125. Okay, velocity 100 meters per second. Find the time taken. This is our target. Okay, this is the main goal. Time taken by the object to strike the ground. Strike the ground to come to this point. Strike the ground and the distance. This one, next guy. Distance to the place from the base of the mountain. We have to find this x. Okay, horizontal. We have to apply to the horizontal part. And time. Time is, every time I say to find time, we have to apply motion equation to the vertical part and for horizontal part. That's all. Okay, fine. Now let's start to do the question. So let's apply. Okay, let's mention this as A, this as B. Okay, first of all, we have to find the horizontal and vertical components. Horizontal component is how much? It is 100. What's the vertical component? It is 0. Why 0, people? It is sent from the maximum height. They say that they project with what velocity? With a velocity 100 meters per second. Horizontally, when it is moving like this 100, it doesn't have a velocity in this direction, vertical direction. So it is considered as 0. The vertical velocity is 0. And all right. So that's all. So now we are going to apply motion equations to here. So we know the displacement distance is 125. Initial velocity is 0. Why? It is falling vertical downwards. And we have to find the time, that is equal to t. And we know acceleration due to gravity is 10. We are going to apply motion equations in this direction. So g is in this direction. So it is positive. Okay, right. Now let's apply. S is equal to ut plus half at squared. Okay, S is equal to 125. Okay, u initial velocity is 0 plus, here plus because this is 10 plus 10, so we can put plus 10 without getting scared. Half 10 is here acceleration, and t squared is going to be t squared. Here this t squared multiplied by 0 becomes 0 here, but here the t is alive. Okay, right. So this makes an equation half. So let's call this part here. So this 2 to this 5 can 10 cancel off every time. That is going to be 5. So 5t squared is equal to 125. So both sides we can divide it by 5. This 5 to this 5 cancels off. Okay, I'm mentioning cancels. So here 125 cancelled by 5, it is going to be 25. So t squared is equal to 25. T is equal to square root of 25. So t is greater than 0. Therefore, it is 5 seconds. So the square root of 25 has two values. It is positive or negative 5. From these two, we have to filter only one part, that is positive 5. Why? We don't have negative 5s. Negative 5 means negative time. We don't have negative time in our universe. Okay, so that's why we are going to omit that answer. Right, now let's move on to the next part. What's the next part, people? It is to find the what? The time taken, we found it, and distance from here to here. So from here to here we have to apply what? To this direction. What is the equation? S equal ut. That's all. S equal ut. So we have to know u and we have to know t. So let's see if you know the t. U. Yes, we know u. What is u? U is equal to initial velocity, that is 100. T. What is t? T is equal to this. From this point to this point, it took 5 seconds. So it is 5. So what is r? S. S is equal to x. So if we apply s equal to x is equal to u is 100, t is 5. So x is equal to 500 what? Meters. 500 meters. So this is 5 seconds, this is 5 meters. That's all. We got the answer. Okay, so here we have to mention what we forgot to mention one thing here. A to B, we didn't mention this. A to B, right, that's all. So finished question, finished. 15 question, finished. Right, so before that, let's erase this stuff. Okay, now let's move on to the 16th question. 16th question, right. 16th question. So what does the 16th question say? Okay, what does it say? So continuously you are going to wash 4 hours, so it is going to be really hard. Okay, even it is hard for me because I'm sitting in one place. If I'm doing it in a physical class, it would be much easy, but here I'm sitting like this for like almost 4 hours. Okay, and computer is here and my tab is here. I'm writing like this, I'm writing like this, and the thing is I'm writing from a stylus. So stylus is a tiny pen. It is smaller than a pen, and I can't touch the entire tab. It is really hard. I can't keep my palm here because it will overforce the touchpad. So my pen is like this, my fingers are like this. This is my thumb and this is finger. Other fingers are like they are like this. I'm not shrinking them, they are elongated. So in the entire class it is like elongated from here to here. It's very hard, but still we have to do everything. Okay, right. Okay, now let's move on to this question. So in this question particularly, this motion is not started from here. Okay, if it started from here, it is a parabolic motion, a fully parabolic motion. But here it is started from this point, start from here and ends here. Okay, so we have to be a little bit cautious. Okay, right. So a stone is projected upwards with a velocity of 90 meters per second. Okay, it is projected upwards. It is projected upwards. Okay, it will be inclined, but it is above this level. It is in the upward direction. Okay, not downwards. Velocity of 90 meters per second at an angle of 30 degrees. They have mentioned the angle, they have given the value, so we don't want to worry. To the horizontal, this 30 is to the horizontal. From the top of a street light, this is a street light. The height of it is 50 meters. Of height 50 meters, the initial displacement is 50. Understand? We have to find the flight time TF and the horizontal range of the stone. We are drawing a stone from the light stamp. So the time of flight from here to here is the time of flight. So these parts are not here. He's not going on this path. He's going only on this path. So this is his time of flight. This part is the only time of flight of this stone. And if it is a fully parabolic path, this would be the range. But the stone is drawn from here. So the range is gonna be from here to here, and this is the range. This X is the range. So that's all. So to find this horizontal range, we have to apply S equal UT. So to find S equal UT, to find this S, we need initial velocity and time. Initial velocity they have given, it is 90. So we can take 90 cos 30 and we can find U. But we don't have this time. What is this time? Time is the time taken from here to here. So here in this time period only, this is flying. So this is the time of flight. So to find the range, we should every time have the time of flight. To find the range, we should every time have the time of flight. We have to find this time of flight because we have the velocities in this place in every case. In every case, we have the initial velocity. They will give the initial velocity most of the time. Okay, so right, first of all, when you're starting a projectile question, what's the first step? To find the vertical and horizontal velocity. Sorry, vertical and horizontal velocity. Let's find it. Let's find it. Okay, so here I'm going to write it. u1 is equal to what? Cos theta, 90 cos 30, 90 cos 30, 90 cos 30. This will be equal to, I said that 90 cos 30 is root 3 over 2, so this will be cancel off, and 45, so this is 45 root 3. I'm going to write it 45 root 3. Okay, right. Then I have u2. So u2 is equal to 90 sine 30. 90 sine 30. So 90 sine 30 is half. This will be 40. That's 45. That's all. 45. This is meters per second, and it is meters per second. We found the velocities, right? That's all. Now what I'm going to do? Now I am going to consider the vertical motion. First of all, we have to consider vertical motion because we can't find the horizontal range without this time. So to find this time, we have to apply equation every time to the what? Vertical motion, because from the vertical motion only we can find a time. Time is dependent on vertical motion. Okay, vertical motion, you have to remember that. I won't give a statement. Okay, right. So I'm going to apply equations for vertical motion. So this is starting from here. Vertical motion, in the sense, I know the initial velocity, that is u2, that is equal to how much? u2 is equal to 45. Okay, 45, I know it. And I know the displacement, that is equal to how much? 50. I know the acceleration I am applying towards up, so acceleration is equal to minus 10. And then what do I have to know? I have to know the time. So time is equal to tf, t, capital T, time of flight. So usat, that will be s equals ut plus half at square. So the distance is 50, initial velocity 45, time is capital T. This is minus half multiplied by 10 multiplied by t squared. Okay, fine. Now I have a quadratic equation. Every time this was 0, now you have a value. Okay, what I'm going to do, I'm going to first of all cancel this to this. That will be 5, ne? That will be 5. So I have an equation with 50, 45 and 5. I can divide whole equation by 5. So whole equation divided by 5, that will be this 50 divided by 5, that will be 10. 45 divided by 5, 9 capital T, minus 5 divided by 5 is 1, so t squared. So I'm going to arrange this everything like a nice quadratic equation. T squared, that is to this direction, I took it to the left hand side. T squared, this 9t to the next direction, minus 9 plus 10. Plus 10 is equal to 0. So from this equation I will get t minus 10 and t plus 1 is equal to 0. So from that I have two equations, two answers. T is equal to 10 second and t is equal to 1 second. Okay, t is equal to 1 second. So from that I have two answers now. So to reach 50, I can go in this direction or in this direction. Okay, this direction. Okay, so from here to here I get 1 second. From here to here, I'm going here. So from here to here I will take this. From here to here I will take this. So 1 second, 10 seconds. Totally it would take, like, I think yes, it would take 11 seconds. But here to here we have to take the highest one. So therefore the flight time is sorry, I'm really sorry. Thing is, this one is negative. Okay, negative. Yes, negative. That from that negative we will get a small information that if it go in the negative direction, it will take negative to reach this height, negative 1 second. So 1 second for here, 10 seconds for here totally. For the whole part, if you apply motion equation, you will get 11 seconds. Okay, so that's a small silly part that you don't want that. Okay, don't want to solve question, but just remember this -1 has a silly meaning. Okay, so from here, therefore time of, okay, let's cancel everything. Okay, I'll write it here. Therefore time of flight is equal to how much? 10 seconds. 10 seconds. 10 seconds. Right, now what I'm gonna do, I'm gonna put other equations. What is it? From here to here, I'm going to put s equal ut. So in this direction, before that, let's write what are the equations that we know. S is equal to x, u is equal to how much? u1 is equal to 45 root 3, and we have t is equal to 10. So in this direction, s equal ut, x is equal to 45 root 3 multiplied by 10. So this will be almost equal to 450 root 3. Okay, this will be equal to, if you multiply 1.732 multiplied by 450, it will be 779. This will be 779.4 meters. You can write it as 779 meters. Okay, that is fine. Okay, that is fine. So that's the answer for the 16th question. 16th question. Right. Okay. All right. Now you have the 17th question. Okay, 17th question. So we can finish the whole inclined motion part in this class. We can move on to the other parts later. Okay. Right. We are moving to the 17th question. 17th question. Right. So what does the 17th question say? Okay. Here again, find the flight time and the horizontal range of the stone projected downward with velocity 50. Okay. Now this is downwards, projected downwards with 50. Inclined by 30 to the horizontal from the top of the street. Okay. Right. So first of all, what we have to find? u1 and u2. That is our target. So let's find u1. u1 is equal to 50 cos 30. 50 cos 30. So this will be equal to how much? 50 divided by 2 is 25. 25 root 3. That's all. u2 is equal to vertical 1 50 sine 30. That is equal to 25. You can see the pattern. You can see the pattern here. Okay, from the first question. So I know u1 and u2. Fine, that's all. So now what? I have to find the time by applying to the what? Downwards part. So now I'm not going to write everything here. Just write this a and b. So from a to b, I'm going to apply what equation? What equation? I know the displacement. Okay, I know the initial velocity, I know the acceleration. I have to find the time. S equal ut plus half at squared, right? Downwards, s equal ut plus half at squared. So distance is 120. Initial velocity is u2. u2 is going to be equals to 25. Take the time as t. Time of flight, let's take it as capital T. Here it is plus. Why it is plus? It is plus because a is towards down. We are applying this towards down. G is towards down, so it is positive. So half into 10 into t squared. Okay. Now again I can cancel this to this. It is going to be 5. It's going to be 5. So 120, 25 and 5 divisible by 5. So I'm going to divide the whole equation by 5. I'm going to divide the whole equation by 5. So I didn't mention it in this step. I'm dividing whole equation by 5. Okay, 120 divided by 5, that is going to be how much? 24. 25 divided by 5, that is 5t, plus 5 divided by 5, that is 1t square. So I get a quadratic equation as t squared plus 5t minus 24 is equal to 0. So from here I get two answers. Okay, I get two answers. I get t plus 8 and t minus 3 is equal to 0. So t is equal to minus 8 seconds, or t is equal to plus 3 second. Okay, plus 3 second, right? So from here, which one should I take? I should take this plus 3, right? It is positive. Therefore, time of flight is 3 seconds. Why? T is greater than 0. Every time is greater than 0, right? Only that. Now what I have to do? I have to apply motion equations in this direction. What is that equation? Okay, from A to B, I'm going to apply this. From A to B, in which direction? In this direction. What's the equation? S equal ut. Every time it is S equal ut. So distance is it's named as x. Initial velocity is u1. u1 is 25 root 3, and the time is 3 seconds. So the final answer is 25 3 root 3, 75 root 3. So 75 multiplied by 1.732. 1.732 multiplied by 75. 5 times 2 is 10, 5 times 3 is 15, 16, 1, 5 times 3 is 35, 36. Here 3, 5 times 1 is 5, then 3 you have 8, so 7 times 2 is 14, 1 here, 7 times 3 is 21, 22 here, 7 times 5 is 49, 50, 51 here, 50 here, 7 times 1 is 7, you have 3 and 2, 12 here, you get 0, 0, 1 here, 9 here, 9 here, 2 here, 1 here, so you get 129.9, get 129.9. 129.9. Yeah, 129.9. So this is the value. Okay, you get 129.9, almost 130 meters, 130 meters, right? So that is this B part. Okay, that is the second part. So that is the answer, and we have completed 17 solved exercises. I mean, from 11 to 17 we have completed 7 solved exercises from here to here. Okay, now if we revise the memory a little bit, okay, let's add a page here. Okay, we have another 2 questions. Shall we move on then? Okay, so we can finish this part and move on to the related question. Okay, right. Let's add a page. Okay, now let's see here. Okay. So you have to remember, people, that every time when you're applying motion equations to inclined motion, you have to remember to find times apply equations to vertical part. Okay, to find horizontal displacements, or you call it a range, apply equations to the horizontal part. That's a horizontal part. Okay, so this is horizontal displacement. This is to find horizontal displacement. This is to find times, and the next one is next one is to find velocities. To find horizontal velocity, do nothing. Why? Horizontal velocity is constant. Okay, so it is much better if I give that part like this. Okay, like this. I delete. Okay, to find what velocity, people? To find what velocity? To find velocity at whatever the point, you have two ways to find it, two methods to find it. Horizontal velocity, you have to find the horizontal velocity, that is constant. That is constant for the entire motion. That's why I wrote it in block letters. That's why I wrote it in block letters. Understand? So vertical, I'll write like this. To find vertical velocity, what you have to do? Apply. What did we apply? Every time to find the vertical velocity here, not this question. These questions here, what did we apply to find the vertical velocity? Here, to find the 16 part, we applied v equal u plus 80. Every time we have to apply v equal u plus 80. To find vertical velocity, apply v equal u plus 80. We can't apply this to horizontal. Why? We don't have an acceleration in horizontal. V equal u plus 80. So if we are applying v equal u plus 80, it should be to the vertical part. To find the velocity, you have to apply for the horizontal part and the vertical part. That's all. Okay, that's all. So this is a little bit, you have to remember that this is a constant. Okay, you have to remember it's constant. So what are the other things they ask? Okay, maximum height. We are going to ask the maximum height. Apply what? V square equal u square plus 2as. To find maximum height, every time apply v square plus u square plus 2as. Okay, to find time, every time to find time. Okay, to find time, apply equations to what equation? Which is this is the equation is s equal ut plus half a t square. So that's it. No any other special factors. These special factors just writing. Motion equations to inclined motion. I'll put this topic as special ways to find values to inclined motion properties. Okay, understand, for inclined motion properties. So write this small note in your notebook. To find the times, apply equations to the vertical part. to find the horizontal displacement, apply equations to the horizontal part. Okay, what equations? So here especially the equation we have to mention, what is it? S equal ut, that's all. S equal ut, S equal ut, S equal ut, that's all. Every time horizontal part means S equal ut. For horizontal part, you, oh, this is not that relevant because you all know that, ne? But the first thing you have to remember is first find vertical and horizontal component of the projected velocity. That is the first step. What you have to find? You have to find the vertical and the horizontal component of the particle's initial velocity which it is projected. Okay, that's what you have to do. Okay, right. Now let's see what's the other next theory part that you have to study. Okay, the theory is above next theory. Okay, the theory is portion of an object projected from a system moving with a constant velocity. Okay, portion of an object. Okay, what they are asking is, you do a trajectory. What means you are a flight, you move and you drop an object, and that object is following a projectile motion. Okay, here the same part. Here you are moving in a van, you are doing a projection, and you catch the ball again by the van, and that is the part. Okay, that is the part. Velocity, right? So that is this. Okay, let's look into this. Portion of an object. Portion, part of an object. Take you have a big bomb here. You have a bomb. You know this bomb is going to blast into only two pieces. You throw it like this. It is moving, and at one point it breaks into two parts. One part is flowing in this project. One part is flowing in like this. The other part is going like this because of the velocity differences. Okay, like this. It is moved like this. Okay, you were coming in a plane. You were coming in a plane. Okay, this is a flight. So that flight is going here. It is moving. After it put the bomb, it is still moving. Okay, still moving in this direction. Okay, in this direction. Understand? So that is a part of the plane. A part of the plane is trajected. It is a trajectory. It is thrown. It is moving like this. It is trajected. So the physical properties of those objects that is projected, we are going to find it. Okay, when a system is traveling with a constant velocity. Okay, when a system is traveling with the constant velocity, this is the what this is the cherry on the cake. You have to know this part. Okay, before everything. Constant velocity only when the object is moving in constant velocity. System traveling with a constant velocity, each object is in that system travels with same constant velocity. When a bus is moving and every people in the bus is moving in that same velocity in that road. Okay, unless they are walking, the velocity of the bus is the velocity of that man, velocity of this woman, velocity of the driver, velocity of the conductor. So velocity, when the bus is moving a constant velocity, velocity of every object inside that bus is moving with that same constant velocity. Okay, therefore we too are moved with the same velocity of the bus. Therefore we are moved with the bus when sitting on a seat inside the bus. When sitting on the seat inside the bus, we also start to move with the same velocity. That is why we see our surroundings moving backwards. That's why we see that surroundings are moving backwards. When you are looking from the window, tell that you are sitting in here, you are sitting in this chair, okay, you are sitting in this chair, okay, this is your hand, this is the window. So you move, you see everything, okay. Let's see that. Uh, this is your seat, you are sitting here, like this, you are sitting here like this. You are keeping your hand on the window bar, and you keep the hand like this. And here is the window, here's the shutter, okay. We are looking from here, so here you can see, oh shit, okay, fine. This is the window, this is you, okay. You are sitting here, your hand kept here, and your hand kept here. You can see that there the mountains outside, the sun, okay, the trees, everything moves in the backwards direction, when you are moving in the correct this direction, okay. That is what they are saying. As we see the surroundings moving backwards when looking outside through the window of a moving bus. This is further clarified by phenomena of sudden forward push faced by us. This is further clarified, okay. This is further proof that this phenomena of sudden forward push faced by our bus, this phenomena that we are going to talk here, is occurred when the bus suddenly moves forward, okay, forward pushed faced by us, okay, right. When the bus was immediately stopped by applying brakes, or when the bus is stopping suddenly when it applies brakes, we are going to front, okay, right. Here we are pushed forward since we are unable to stop ourselves suddenly from the bus. So we are pushed to this direction because the bus is stopped, but we don't have a force to stop us in this direction. Bus has brakes, but we doesn't have anything in front of us. So we move front and we knock at the front seat's back part, okay. So by catching that only, we have a force in the opposite direction, we stop, move, okay, right. Therefore, an object projected from a moving system has the velocity of the moving system also in addition to the velocity of projection. So when an object is projected from a bus, okay, when it is projected, it has the vertical horizontal component of this projection, okay. If you project it by u, this is u cos theta. When this is theta, this is u cos theta. You have this horizontal velocity, you have this vertical velocity, that is u sin theta. And addition to this u cos theta, you have the velocity of the bus, think that the bus is moving with v1 velocity. Your speed is now u cos theta plus v1, Why? The object has the velocity of the bus. That is what I proved from that bus example. You have the same velocity as the bus and you have the projected velocity. That's all. Therefore, these type of questions can be solved in the usual way by taking the component of velocity gained of the motion system into consideration when considering the horizontal and vertical components of the object. Therefore, these type of questions, like the questions that we are going to talk here, can be solved in the usual way. The usual way, what we do, taking the components of the velocities. We are taking the components of the velocities, and from that we are going to take the horizontal component. We are going to add the horizontal velocity of the bus as the horizontal component to the object. Okay, right. So we have the next parts to do, okay. These trajectory parts, we can do this whole exercise, and then we can move into relative velocity, relative motion part the next month. Okay, then right, then let's wind up the session. So now I'm going to wind up the session. So good students, okay, today we talked about inclined motion, solved exercises, and now you can do MCQs from the what, question tube. Okay, I'll show which questions you can do, okay, right. Okay, now let's look into the question tube. This is the question tube now. Okay, question tube. This is from remote under gravity. So I said this question to do. I said you have to do these questions, right? I don't know if you'll remember. Okay, I'll discuss these questions next time. Okay, questions regarding inclined motion under gravity. Shown in the figure is a particle projected with velocity u inclined by angle theta. Explain how the horizontal velocity component u varies toward the motion. Okay, let's do that another time. Okay, and why doesn't this change? Because there's no any force, unbalanced force. We don't have unbalanced force in this direction, so the velocity doesn't vary, it is constant. Okay, explain how the vertical velocity component u varies with the throughout the time. So I have to explain vertical velocity. It is same as the vertical velocity of a motion of an object under gravity. Vertical motion of object under gravity. What is the maximum height reached by the particle parabolic path? What is this maximum height? U squared over 2g. What is the time taken to reach the maximum height? Maximum height, that is u over g. Time of flight, that is 2u over g. When this is sine theta, that is 2u sine theta over g. That's all. Build up an expression for the total horizontal range. R is equal to, as I remember, 2u sine 2 theta divided by g. Okay. Find the angle of projection for the maximum horizontal range. For the maximum horizontal range, we have to find the angle, that is 45 degrees. Show that there are two angles that give the same horizontal range. We have to say that we have two angles. One is this angle, one is like this angle, to find the same horizontal range. Maximum horizontal range. Build a relationship. Now we have to build a relationship between maximum horizontal range and maximum height attained during the motion. So the maximum horizontal range is when 45, and maximum height is attained. Maximum height is attained during the same motion. Okay. Relationship between maximum horizontal range and maximum height attained during the same motion. Okay. So we have to find the maximum height, the angle of maximum height, and we have to find the angle or maximum range, and after that we have to find the maximum height, h max and r max, and find the ratio of that. Okay, likewise you have many questions. You can do this, you can do this, okay, you can do this. So let's move on to MCQ part now. Let's keep these questions so we can do it. Okay, MCQ part. Okay, MCQ part. Projectile motion. A fall down from rest, B projected 50 meters horizontal. Vertical velocities if B collides on A, time taken for collision. From here to here, it is going to collide. From B to A, you have to put motion equations. From here to here, you have to find the time, and from that time, from here to here, you can put S equal ut plus S equal ut. Okay, so you have u, you have t, you can find the you have u, you have s, so you can find the time. So with that time, the time taken for the collision, it is really easy, you can find it. So here to here, it is going to collide, you can find the time. That's all. Because you have some questions, try to do these questions. I won't force you, I won't tell you compulsorily to do these questions, because today only we did some short exercises, so you can do it in future. Okay, right. So tomorrow, the paper class, I hope to do some questions for you. And the next class also will be a recorded class, and the other classes, paper class, also will be recorded class. Today is 15th of August, 16th of August. Okay, this will be on Monday, 16th of August. Then you have 22nd of August, and 23rd of August. Everything will be recorded. 22nd, my birthday. 22nd October is my birthday. 22nd August is not my birthday. My birthday is in October. Yeah, 22nd. Okay, right. 22nd and 23rd, these two also will be recorded class. So the 28th and 29th, I am not sure, I'm not sure, mostly it also will be recorded class. So in this month, 3 weeks will be recorded class. So make your stamina high, to watch recordings, okay, and complete the note. I'll send the note also. Right, then have a nice day. Goodbye. Goodbye. Okay.